is because we want to set it up telling it that we haven't found it, and then inside the for loop, if we find it, then we can set it to true. Let's have a look. So after the for loop, we can print contains to the screen, and then inside the for loop, what we can do, as we've seen here, it returns back every single character. So you'll get back C, sharp, then the space, then I, then S, and so on and so forth. And what we want to do is we want to go through each of the characters and then just ask if the variable is equal to C. If C is equal to C, then we can assign this to true, and then go through if hashtag is equal to C, if space is equal to C, and so on and so forth. So we can write an if statement here that says message, square bracket I, is equals to, apostrophe C. And the reason why it's an apostrophe is because this is a character, and this also returns us back with a character, so we need to compare them both like that. If we use a string in here, then it might complain that we're trying to convert between a char and a string, and it won't let you do the equals equals operator between two different variables. Maybe what we can do instead is to follow the approach that we used before and use the equals function and place our C inside here. So if the character that we're currently up to inside the for loop is equal to our C, which is what we want to search for, then we can set our contains variable equal to true. We don't need to write an else statement in here to set our contains to false because we've already gave it a value at the start. If we didn't have this value, then it'll be beneficial to do this. But since we have it, then we can remove this other path and we don't exactly need it. So let's have a look and see if this works. Perfect, it says true. Maybe we can change this character to something like A and make sure this works, which it does as well. So perfect, so now we've made our own mini little contains function inside here, and we can also use the C# library one. But the purpose of this exercise was just to show you how we can iterate through a string variable and then decide what each of the characters can be equal to, and then we can decide if they're equal to another one, and then let the user know that we found a match for their search term. So far in the course, we've covered the equals function and the contains function when you're searching through strings or trying to find values. Let's have a look at a method that makes sure a string is valid before we can process information on it. So in this quick example, we have a name output, we read in the value into a string name, and then we simply output it to the screen. If we run the code and just press enter, then it says your name is blank. And we don't really want that because we want to check if your name is equal to something before we continue. So let's look at some methods. So we have if the name is not equal to nothing, and then let's just print 0 to the screen. And that's one of the methods. And we can say if name is not equals to quotation marks, then let's print out number 1. So what this is doing is checking if the name is not equal to empty quotes, and then this is doing exactly the same thing, except we're using the equals method. And let's just run the code and press enter, and you can see the 0 or the 1 doesn't appear because it's detecting that it contains nothing. So if we type in a real value, we can see 0 and 1 coming up. So these are both valid ways of checking if the string is not empty. So let's look at a third one. And this one is actually very important for reasons I'll explain in a second. So inside our string library, we have is null or empty. So we place our name inside here. And let's see what this says now. Indicates whether the specified string is null or it's an empty string. So this can be very effective. So what this reads now is if the string is null or empty, then we print a value. But we want it to be not null or empty because it wants to have some contents. So if we type a value in again, you'll see now we get all 3 numbers. And what them 3 numbers mean is that it's passed all of these checks, and each of these checks just ensures that the value has got something inside. And that's fine, but it can be slightly problematic for this reason. Using this method and this method are fine in some cases, except as it says here, it checks if the string is null. And null means it doesn't have a value, but it just has nothing instead of something. Let me demonstrate. If we assign the value of empty quotation marks, this actually has a value, but the contents is empty, but it's still a string as it comes up in here. If we assign this the value of null, then it's just a keyword that we can use to denote that this literally has no contents. It's not that it has an empty string, because an empty string is still actually a string, whereas a null, it just means the variable is blank. Now this is where the issue arises. If we try and call a method on something that's null, watch what happens. we actually get an exception and our program just crashes. You can't run any code on something if that variable is actually defined as null. It doesn't mind if you check the value of it, but if you try and run a function, then you've got a problem. So if we comment this line out, this ensures everything. It ensures it's null or it's empty. And this is the belt and braces option, because if it's null, we don't actually get an exception when we try and run this code. As follows. We get the 0 showing up because our variable has something that's not speech marks, and it's actually null. So we want to avoid this option as well, and also avoid this option in case our string is actually genuinely null. Using is null or empty will check both for the value of null, which it is right now, and if it's got empty quotes, e.g. the value is empty. So if we just run this again and have these two paths commented out, we can see that 2 is not appearing. If we change this back to our console read line and we try and do it, then we get our number 2 because it's validated that this string variable is got something inside it and the variable is not actually null. This is a very good way of being able to make sure that your program doesn't get exceptions, as we'll call in these equals. If you want to call equals, then call it inside here. You can check if that variable equals something by simply placing that if statement inside here after you've validated if the name variable actually has some contents. If it's null or it's empty, running equals on it will just break the code further. And you don't need to check if it's equal to something in here. Maybe you were checking if the value is equal to ABBA or something along them lines. And now if we run it again, we actually get the output correct. It's best to nest them like this because if you run this function on something that's null, it's actually really safe. But as you saw previously, if you run a function on something that's null, then you're going to get a null reference exception and your program will close down and break. You want to avoid exceptions at all costs, so nesting it inside a is null or empty check will be perfect for your code. It improves the stability of your program to ensure that exceptions don't happen. So in this exercise, I want you to ask the user to input any message, and then I want you to print the message in order, character by character, and then also print it in reverse, character by character. Let's get started. So we could just have a console write line, but let's change it to a write and just say enter your message, colon, and then speech marks, and then just have a string message equals console.readline. Perfect. So in order to be able to loop through the string message, we need to have a for loop. If you remember from our previous videos, we can have this string variable followed by a square bracket, and then we can have an index inside, and that will print us back any sort of index based on that position. So if we just have this is a test, then it's printed as the t because that's the first index, and so on and so forth. So what we can do with this information is take what we can do with the string index and then also use the property which is .length, and then use these two values to be able to process. This is a test. So we have the first character, square bracket 0, and the last character is at length 14. So our message variable now contains 14 characters. Obviously when I close the program, then that value is lost and I have to re-enter it. But because of that exact reason, we would always use .length because we never know how long the user's input is going to be. So we can have a for loop. So we can say for int I equals 0, I is less than, and we can use the message.length here, and then we can say I++. So we want to start at 0 because our first index position is indeed 0, and we want to go from the index 0 all the way till the length. Now in that example, I just printed out 14 for the length. What you got to realize is there might be 14 positions, but there's only 13 indexes. So it's not actually 13 index, it's just up to 13. When you start at 0, going from 0 to 13 gives you 14 positions. So when we're saying 0 is less than the message length, then that'll actually take us from 0 to 13 instead of 0 to 14. If we made this greater than or equal to and change this to a 1 for example, then that's going to go from 1 to 14, and first we're going to miss out the first character, and we're actually going to go 1 over the message length. So you always want to start from 0 if we're going through the entire string. So this will go from 0 to 13. And then here we can just have a console write line and just print message square bracket I, and then just for the time being we can comment out these lines just so it doesn't saturate the output. So let's run this code and see what happens. This is a test, and then we get them all on separate lines. Maybe we can just use a console.write instead, so we get each character on the same line instead of a new line character being outputted at the end of each of the lines. So we can say this is a test again, and there we go, we get this as a test outputted as well. So now that we've printed that in order, let's see how we can print it in reverse. So just a quick little tip, throughout this course I've been quite hard on you. I've made you write the for loop out exactly the way it should be, but all done manually. This is so you can get used to the syntax, and after a while, once you understand exactly what to do, then what you can do is when you type in the for, you can see that it says there's a for snippet. Tab twice to insert the for snippet, and we can do that now. And then it actually gives you a little bit of an output. You can see these sections that have been highlighted. The reason they're highlighted is once you're done with one section, you can actually press tab and it'll jump to the next one. So now my cursor has jumped on the length, and we can type in message.length. If I press tab again, then it'll just keep cycling through them until we're done and we can press escape. Upon pressing escape, then it gets out of the little message, and there we go. We've now just defined a really quick for loop. Please only use this once you're comfortable with writing for loops, and don't use them immediately because you might get stuck on what to do and how to do it, so it's best to always write the for loop syntax out from scratch so you can get used to the 3 different sections. So this is actually a for loop that goes forwards. It's going from 0 to 13, but what we actually want to do now is go from 13 to 0. So let's actually change this for loop completely, and we can do our little shortcut again. So if we do for, and then we don't actually want to start on the value of 0. We want to start on message.length, and then you want to -1. And just as we said here, we never actually want to get to the length because we want to go from 0 to 13. So if we want to go backwards, we want to go from 13 to 0. And the only way that we can get this 13 is by getting the 14 value, which is message.length, and simply minusing 1. So now that we've got our first variable, which is int I equals message length -1, which will give us the 13, we want to go from I, and instead of less than, it's going to be greater than or equal to, and then we actually want to change this to a 0, because we actually want to stop at 0 in this case. And then we don't want to use I++, because if we start at 13, we want to go down in 1 instead of up in 1, so we can simply just do -. We can take this exact line and print it out to the screen. And if we just print something small in between, like a hyphen, just to separate the 2 outputs, and let's see what happens. Test. There we go. So we have test, and then T, S, E, and T is now in reverse. But now you might be wondering, if we had a shortcut for the for, what's this for with an additional R? Code snippet for a reverse for loop. So if we tap twice, you can see that we have exactly the same format. Int I equals something -1, which we have right here, and then with I is greater than or equal to 0, as is we have here, and then we have I minus, just like here. So we can literally just change this into message.length, and then these two now are exactly the same. So just copying this down will get us exactly what we need, but obviously we just wrote this, I just wanted to show you the shortcut. So let's try it with a longer string. This is a test. There you go. And if you wanted to, you could just print these on separate lines. So you can just change this into a right line, for example, and have it like that. It doesn't really matter. The rest is up to you, but the task is just so you can print it one way and then print it the other way. I realized that what you can also do is just simply print a console write line and have message in there and just get rid of this completely. And the output will still look exactly the same. There you go. And the reason why I told you to write the for loop is not because it'll be easier if you do this, it's more for your educational learning purposes. Having more practice to how to iterate a string variable is very helpful for the future and you can understand it fully. If you just print it out to the screen, then you're not learning anything extra, you're just applying what you already know. So let's just have a quick recap. We asked the user to enter the message, we store it into a string variable, and then I demonstrated that you could use the square brackets to output the first index. Then you can output the length of the entire variable. Using a for loop, we can go from 0 to message length, which will give us from indexes 0 up until 13 in this case, and then we can go through I++, incremented in 1, and then we can have a console write, which will just print out message index I for the index that we're currently up to, and then we break it off with a console write line just in the middle, because these are printing on the same line, so we need to insert a new line character at the end. After we've done that, what we can do now is print it in reverse. And now we can do exactly the same thing, except from 0 to 13, we go from 13 to 0. So we start at the message length -1, because the length was 14, and now we -1 to get to 13. And we're going from I is greater than or equal to 0, because that's the value that we want to stop at. And then we can do I minus minus. If we were to take out this equals operator, let's see what happens. Test. And now we're actually missing the last character, because what we've done is we've actually went from 13 to 1 instead of 13 to 0. So let's put that back in and make sure it works. And then we have T set for test. And then we're outputting the exact same thing in both for loops, because we're simply just printing the character that we're currently up to. And because this for loop starts at 0 and this for loop starts at the length -1, then they output in the same values, or what it appears to be the same values, it's just starting at different indexes. In this exercise, we're going to be building some sort of a password validator. These can be present in something like a register form, where you ask the user to enter their password, and then enter it again to make sure that they've entered it correctly. If you want to ask the user to enter their password in twice and store them both, check if they both contain something. If they do, we can print out password match. If they don't, passwords do not match. And if they both contain nothing, then you want to output please enter a password. So let's get started. First, we can have a console write. We can have enter password, string password equals console.readline. And then we can just copy these two lines down using Control D. And then we can have a password C for password confirmation. And we can say enter password again. And let's just print these out to the screen just to make sure we know what's going on. Just like so. So we can have ABBA and then ABBA again. So now we have both ABBAs stored, and that's fine. So let's see what we can do now. We need to check if they both contain something. So what are the different ways that we can do this? So we can have if password dot equals, and then we can make it equals to string.empty. And because we want to check if it's not empty, then we can simply place the not operator right at the start. And then we can join them with another one, not password dot equals, and then exactly the same thing, string.empty. But in this case, we don't want to use password, we want to use password C. There we go. So if we've came into here, then that means they must have entered something. So let's just quickly do our exit path, which is if they're empty, please enter a password. So we can say else, and we don't need a condition here because if this were to fail, then it has to mean that their password's empty. So we can have a console.writeline, and we can just do please enter a password. And let's just test if this path works first, and we just press enter twice, and we get please enter a password. And maybe if we type something in for both, and then we get nothing, because it's actually came into here now. Perfect. So if we come through and we can say password equals password C, or we could use the equals function and we can say password dot equals and then password C. And if they both equal to each other, then we can print out passwords match. There we go. And if that were to fail, then we can print out passwords do not match. Here we go. Let's run that and find out. ABBA and ABBA, and we get passwords match. And if we try ABBA and ABBA with two A's, and then we get passwords do not match. So what are some other ways that we can do this? You can structure this completely differently. Right now we're doing both checks in one single if statement, and we can actually split this up into two and then provide a different error message. So right now this says please enter a password. You might have entered the second one but not have entered the first one, or vice versa. But it doesn't matter because you have to enter both of them in order to pass this validation check. So what you could do instead is actually put another if statement inside and paste this one inside here, and then just keep these as two separate if statements, and then you can actually provide different error messages. So let's nest this in one deeper. So we can say if the password is not equal to empty, and if this returns back true, then this variable has something inside it. And then once we go inside these curly braces, we get another check, and if the password C is not equal to nothing, then that means if we've came in here, then we pass both of these validation checks and both of them contain something. And then we can proceed to check the variables. So what you can do in the first else statement is you can say please enter a password. But on the second one, so just after this curly brace, we can have another else statement and we can say please enter a password confirmation. So I know that was a bit quick, so let's just have a quick recap. So we can have one if statement that processes the first password that you type in. And if this is empty, then it says please enter a password. And if it's not empty, then it'll go inside this curly brace, hit the first line, and check if the password confirmation is not empty. If it is empty, then it'll say please enter a password confirmation. If both of these return back true, then it'll go inside the success path, in which it will actually check if password is equal to the password confirmation, and we can say the passwords match, or if they don't equal to each other, we can say the passwords do not match. Let's run that and see what we get. So if we type something in for the second one but not the first one, so for the first one we just press enter, and then let's type something in for the second one, and it says please enter a password, and then if we run that and do the complete opposite, type in P, and then press enter for the second one, then it says please enter a password confirmation. So you can see immediately what we can do is provide a different error message for different situations. If you include these both in one line, then you can only give out more of a generic error message. This is similar for when you go to log in, and when you get your password or email wrong, it doesn't say which one you've got wrong, it just says them generically which one you've got wrong. It says invalid credentials or invalid username or email. It'll say them generically like invalid username or password, but it won't tell you which one it is because hackers can exploit this and you don't want to be doing this. But in the case of a password confirmation, and this is just for a register form, then it's not exactly the worst thing to do this, because sometimes what you'll see is the text boxes might go red to indicate that they're both not equal to each other, and this is fine on registration, but it's not fine on the login. What we can also do in here, once we've checked if they're both not equal to something, we can actually just validate how long the string needs to be. We can have if password.length, and let's say you had a restriction on it can only be over 6 characters, and we can say 6, and password c.length is greater than or equal to 6. And once it passes all 3 of these checks, then we can check if they're equal to each other. If they've got something inside, and if they've got something inside, and if they've got both the length is greater than or equal to 6, then we can check it. So we can have something like password, and then this returns back with password matched. If we have something like ABBA, then it's actually returns back nothing because we don't have an else for this specific bracket. So we can say else, console write line, please enter 6 or more characters. So if we type in ABBA twice, then you can see we get this message now. Please enter 6 or more characters. So right now we have a validation for the first password and the second password and for the length, and if all these checks go by, then you can process the actual passwords that they've entered and check if they're equal to each other. You can technically do all of these checks in one line, it'll just be a pretty long line, but what that means is you can't have 3 separate error messages like this. If you have it processed in one line, the only error message that you can give is very generic. There's no one generic message that can fit for password empty and the confirmation password empty and for the length. So maybe what you could do is chain both of them to be check if they're not empty, so then you can process a message with something like please enter a password, and then you can have another check for the password length just to let them know that they need to enter 6 or more characters. Splitting these off into 2 separate checks is going to be very helpful because it'll let the user know something a bit better than a generic error message. So in the previous examples throughout the course, we've actually talked about using the toLower function. And I said in majority of cases where you want to actually compare 2 different things, you want to actually use the toLower function or the toUpper function. And you can achieve this by having toLower just here, and then also toLower just here. Now the problem with comparing if they're both equal to each other but checking the lowercase values is this is indeed a password. If you're checking if the user has inputted any capitals, lowercase, symbols, etc., then there's no point in applying a toLower function because that will just ruin their actual password and reduce the security. So in certain cases you don't always want to use toLower and toUpper for comparison, you want to just check the values straight up. And the same thing is when you're doing a login, you don't want to be checking their values lowercase because that's their login. These are some of the specific situations where you don't want to be using the toLower function if the data that you're processing is pretty sensitive and will be messed up if you use the toLower function, that you should always avoid it. Passwords fit this perfectly, and usernames as well. If someone's added some capitals inside a username, then you don't want to ruin that by doing lowercase or uppercase. If your username is spelt like this, and you try and log on like this, then they're not equal to each other, because this will probably be two different accounts. You can have an account with a capital B, and have an account with a lowercase b. So you don't want to be lowercase in their input and then doing a comparison, because what you might actually retrieve is a different account than you're looking for. So now that we talked about stuff theoretically, let's see how we can do things practically. So as you heard in the last video, arrays are a way that we can store multiple variables of the same data type in one little group. So if we had something like num1 equals 5, int num2 equals 10, int num3 equals 15, and we had a similar case in one of the exercises like this, where we had to work out if a triangle was actually a triangle. So we asked the user to input 3 different angles, and then we stored them all, and then we added them up after, and it looked something like this. In total equals num1 plus num2, and then finally plus num3, and then we had some sort of if statement after to check if the total was equal to 180. And then we did something in the curly braces, just output that it's valid, and then else output if it's invalid. You can see how this gets a little tedious. We have to create a new variable every single time we want some more data to be stored. And in this case, we just simply want another number that we can store, but we have to just keep appending 1 to it. In that case, we could have angle 1, angle 2, and angle 3. But how about if we had something that just called angles? For now, let's just talk about how arrays work and how we can use them, and then after I've went through this example about arrays and taught you what to do with it, then I'll go get the code from the exercise from the triangle video and actually transform it into using an array so you can see what the difference is and how the new code will look like. So let's get rid of this little section. So now that we've got 3 integer variables, let's see how we can do this another way. So the syntax for arrays, you first type in the data type that you want, just like before, and then you add on a square bracket and a closed square bracket. There's nothing that needs to be inside as of right now. Then you press space and type in the variable name as per always. And then we can make that equal to new int 3. So what this side of the equal sign means is we want a new instance of an integer array and we want to have 3 positions. Since we have 3 variables here that we want to store, we need to have 3 positions to store them. So this line in total says that we want an integer array, we want to call it numbers, and we want to instantiate our new integer array with 3 positions. Instantiate is just the term that we use when you turn something into a new class. At this point, if we don't use new, then we're going to get a compiler error because it's unsure what this is trying to tell you. It's trying to store an integer inside an integer array, and that makes no sense. So it won't recognize the square brackets in this case because it has no idea what it's trying to do, and this syntax is completely incorrect, so the compiler doesn't know what error message to give you. So we can have a new int, and what we can do now is by using the square bracket reference, we can actually specify these 3 variables inside our numbers array. So now we have access to numbers 0 equals 5, and then if you use Ctrl D to copy this down twice, we can change this to 1 and 2, and then print 10 here and 15 here. So now this is exactly the same as this. We have 3 integer variables defined separately as 5, 10, 15, and now that we've created an array of numbers, we can specify all 3 of these values inside our numbers array. So instead of having 3 individual variables now, we just have one that holds everything like a group. And just to show you how this works, if we have a console write line, we can say num1 space num2 space num3. And if we use Ctrl D to duplicate that down, then what we can have instead of these num1s is simply just place these values inside. Change this to 1 and change this to 2. And what you should notice is these 2 lines are going to print the exact same values. There we go. So in this example, we've took our sloppy code that revolves around appending 1 to this number, creating a new array, and then printing it out. So let's say we want to actually use these to read in values from the console. What can we do? And you'd use these exactly the same as how you'd use variables up here. This is just an integer variable at a specific position held inside a group. So we could simply have a console write line, delete the write and just say enter a number. And then instead of storing 5, we can say convert to int32, and then we can have a console.readline. And that will read in from the console, convert it to an integer 32, and then store it into the first position of our numbers array. And now if we just copy this down twice, and we can get rid of these two lines because this is just storing it statically, and add 1 and 2 to here. So now what we're saying is enter a number, store it into 0, 1 and 2, and let's see what happens now. So now we get asked the numbers 10, 20 and 30, and you can see that they've been stored here. Of course these haven't changed because this is still referencing our static variables up here. So what you can see in this example is now that we've made an array, we can specify each of the values very easily inside here. And if we wanted to have a number 4, instead of having to duplicate it and rename it and change the value, for example, we can just simply turn this into 4, duplicate this little section, and then just change this to a 3. One thing to note, in C# and many other languages, almost every single index will start at 0. In the last section we covered the string functions, and they also started at 0 when you're dealing with strings and their positions. When you have a for loop with a string, then you always want to use index 0 as the first position. The same is true here. We have 4 positions, which means it goes from 0 all the way till 3. It never goes from 1 to 4 or from 0 to 4. These are bad values, it always goes from 0 to 3. You might be thinking, this looks really good, but when we go to print it, we're going to have to copy and paste this little section, add another one and rename this to 3. This gets a little bit tedious if we're just trying to print them all to the screen. So let's see how we can fix that. We can use a for loop for this. So we can have for, int I equals 0, I is less than, and then we can have numbers, dot length. And if you notice from iterating through a string variable, the syntax is exactly the same. We have a dot length property on the arrays as well, as we do with a string variable. So in order to print out this line, what we can do is print one of them every time we go around the for loop. Instead of using a console write line, we can just use a console write. So we can have console.write. And then what we can simply do in here is we can say numbers, square bracket, I, and then we can have a space right after it. Just to mimic what happens here, we have the number printed out, and then a space after it, number printed out, a space after it, and so on and so forth. So let's see what happens now if we run the code. 10, 20, 30, 40. There you go. So you can see that these two lines are exactly the same. And now what happens is, let's just comment these two lines out. And if we were to change this to 5, and we can duplicate this section, change this to a 4, and then now we have 5 variables stored, and we don't need to touch this for loop because the numbers.length will get updated anyway. So we can have 1, 2, 3, 4, 5, and you can see all 5 variables have been printed automatically. What also is quite tedious here is we're having to add another one to this, just so we can ask the user how many times that they want to enter a number. Again, this is quite tedious, but we also have a fix for that. Because we know how many times we want to ask the user to enter a number, then we can use a for loop to iterate through and ask the user. As you can see, every single line here is exactly the same except for the index position that we're dealing with. And the same is true for this for loop. This line will always be the same as we're printing out here, and the only thing that changes between this section and this section is the fact that this says 1 and this says 0. So we can translate this into a for loop to make it dynamic. And we can do exactly the same thing above here. So let's actually copy and paste this for loop because we want to do exactly the same approach. We want to go through all the positions inside our numbers array, and then we can actually ask the user to enter a number in. So let's block comment out this massive section, and then we can take one of them and place it inside the for loop. So now we're asking the user enter a number, and then we're storing it inside index 0. And of course, if we keep using index 0, then it's just going to override the first one and we're not going to store any data. So we can change that to an I. And let's see what happens when we run it now. 1, 2, 3, 4, 5, and then we get the 5 numbers being printed. This is awesome because what we've got now is 5 output commands coming straight to the console just from a for loop. The for loop is responsible for printing them all out to the screen, reading in the value, convert it to an integer, and then storing it inside our array. And then we have a separate for loop to print it out to the screen. What's really powerful about these two for loops that we've built is if we want to have 10 numbers now, we simply just change this to 10 and then just rerun the code. As you can see, we now have 10 numbers. There you go. So what we've just done, if we move this code down a lot now, just so we can have it close by, we've made our entire program that was actually pretty lengthy into just a couple of lines and 2 for loops. One for loop is responsible for looping X amount of times, X depends on whatever that number is, and then we go through and ask the user to enter a number, read it in from the console, convert it to an integer 32, and store it within the array. After this for loop has finished running, then we have all the numbers stored inside our array, and then we can go through and print them all out to the console. Another way we can print this out to the screen is by actually using a for each. So we can say int num, and then we want to be a number inside our numbers. So for each of the integers inside the number, we want to create a new local variable called num, and then we can use it in here. And if we take this line and copy it down, everything's exactly the same, except we don't need to specify the main array numbers now, and we don't need to specify the square brackets. We can just change this completely and replace it with num. And if we just make this number smaller so we don't have to output a lot of values, 1, 2, and 3, and you can see that they're exactly the same. There's no line between them because I don't have a console write line, so let's quickly add that in. And there we go, 1, 2, 3, and you can see they're outputting the exact same values. The reason why I needed a console write line is because these for loops are using console.write. The problem with console.write is, even after finishing writing all of the lines, it doesn't continue to the next line, it stays there. So if I don't break up the 2 outputs with the console write line, then all 6 outputs from the console write and the other console write will all go in one line. This is just for demonstration purpose anyway. Either one of these solutions are fine, more people tend to use this one. The problem with these 2 options is you can't always use them interchangeably. This one will always go through every single position. It will always go from 0 and it will always go to the length. The problem with this for loop is you can't choose how many times you want to iterate through before you stop. There might be a very specific case where you have a big array of data, but you only want to select a specific range. If you had an example where you had 1,000 array positions, so from 0 to 999, and let's say you wanted to request and run a for loop from 500 to 600. So you would literally type in 500 in here, and then 600 inside here. And this would be fine as long as your array has that many positions. But with the for each loop, if you run a for each loop on a 1,000 length array, then it's going to go through every single position. In some cases you might not want that, and you only want to go through specific cases. So if you know you're going to go through every single case, then you can use the for each. But if you know you're going to go through a certain amount of cases, then it's always best to use the for loop. Okay, so we covered quite a lot in this video, so let's just have a recap. So initially we started off saying we have our num1, num2, and num3, that we had our static variables stored inside there. And then we created our integer array, which is now down here. And just to make it a little bit easier to store multiple variables, because if you wanted 5 variables, you'd now have to duplicate that and change that to number 5, and this will get very tedious if we had something like 10, like before. This is very long, and you don't need to be specifying number 10 in your code, because this also hurts the readability of it. Using arrays can solve this problem quite a lot. You can easily specify an array using this notation, int square brackets followed by the name, and you make that equal to a new int 3. The 3 can be any number that you want as long as it's a whole number, because this tells us how many positions that we've got. We then outputted lots of values to the console and read them into our array, but we had the same problem as we did above, where we just had to keep duplicating the sections. So what we did to prevent that is by writing a little for loop that went through every single position in numbers array, outputted something to the screen, read in the value, converted it and stored it into the array, and then after all that was done, we can use a for loop or a for each loop and print that back to the screen. Now that we've finished the base content of this video, and because I said at the start that I was going to take the triangle exercise and convert that into an array, so let's do that now. So now I've copy and pasted the solution from the triangle exercise straight into this project. I've just block commented everything above just so it doesn't interfere with our code. So let's just run this code to familiarize us with what's going on. So if we enter 60, 60, and 60, then it says valid. And if we run it again and enter something else that doesn't equal to 180, then we get invalid. So let's see how we can make this code a lot better by the use of arrays. So as we said before, we don't want to be using this angle 1, angle 2, and angle 3. let's make it int square bracket angles equal new int, and then in this case we have 3 angles. And what you could do as well is you could say const int angle count equals 3, and then you can simply use that inside here. So later on in the code, if we wanted to specify this to a different value, we can just change that later on. So now that we've got 3 angles, we can get rid of these 3 lines and write ourselves a little for loop. So I goes from 0 all the way to the angles.length, and then every single time we go around in the for loop, we want to say console.write, enter angle 1, and then we can say angles square bracket and not 0 in this case because we don't want to be specifying an index, as it will go from 0 to 1 to 2. We want to be using I because we're inside a for loop that's already going through all the indexes for us, and make that equal to convert to int32 and then a console.readline. Now we've got all the values stored inside here, let's deal with this problem. So if we just comment out the total for the time being, let's run the code. Oh, we have one more error down here, sorry. Let's run the code again, and we can say enter angle 1, and we can type the values in. But as you can see, we've got angle 1 for each of the times. What we can do in here is use our I index to print out the value. So we can turn this into interpolation, and then wrap the 1 inside curly braces, and we can simply change this 1 to an I. And let's see what happens now. So we have enter angle 0, and then 1, and then 2. And this is fine, but humans don't like reading 0, they like reading 1, 2, and 3. So what we can simply do is say I plus 1. And because we're using I and then adding 1 to it, it's not going to affect the variable inside the for loop, so there's no problems by doing this. This is simply just for the output purposes. So now we can have 1, 2, and 3 just showing up like that. Perfect. So what we can do, now that we have all the angles stored, now we need to replace this line by writing a for loop that can add up all the values for us. So we can have for each int angle inside our angles, and we can just say int angle sum plus equals angle. The problem with this is we can't specify a new variable inside here and then use it outside an if statement. So what do we do? In this case, you want to take angle sum and initialize it outside the for loop and then give it a value of 0. And then inside the for loop, we can remove the int and we can say angle sum plus equals the whatever angle that we're currently up to. So if we had 3 values, that's going to say 0 plus 60, and then take that value and add another 60, and then take that value and add another 60. So it'll keep a running total for us. And if we just print out angle sum to the screen, let's see what happens. 10, 20, 30, and now we have 60, and that's the correct calculation if you add them 3 together. So now that we have a running total for angle sum, then we're pretty much done. If we get rid of this line of code, which is our previous total, and we actually bring back our if statement, there you go, there's no error now. And all this is doing is checking if the angle sum is equal to 180, and then print valid and invalid. So we can have 60, 60, 60, and it prints out valid, and let's just comment out our output. And then we can have 60, 60, 59, and then it prints out invalid, which is the exact same behavior that we saw at the start. So let's remove the extra code in here and keep it like this. There you go. So now we've got our solution just like this, and it's a lot better because if triangles were to transform in the future and we wanted more than 3 sides, then we can easily update this value. Because now that we're using arrays or we're using a for loop to enter out the values, what we can do, we don't actually need to store it. What I mean by that is we can actually just get rid of this array completely. Let me demonstrate. We can take this angle sum and place it underneath here. We can keep the count so we can use that in the for loop. So we're going from 0 to 3 because that's our angle count. And then we can get rid of all of this. And let's see what we can do now. So we have an angle count equals 3. So we go from 0 to 3, which will just do, as we said before, from 0 to 2, because it's less than the angle count. And let's just print this to the screen and see what happens. So the output's still exactly the same, but what's happening is these values are not being stored. They're just being shown to the screen and then not done anything. There is no equal sign here to assign it into anything. So what we can do is we can say angle sum plus equals the value straight away. And now if we try it 60, 60, 60, then we get valid. The main differences between these two situations is, in the first one we used an array to store all the different values and then we added the total. But if we're not going to use these values after, then what's the point in storing them? We can just use a for loop to ask the user how many times they want to input the values and then just add them every single time that they add the calculation in. And at the end we could just simply use a conditional operator to be able to print to the screen whether it's valid or not. But let me just undo that solution so I can show you the array solution and we can have a quick recap. That was just an extra little tip, just in case you wanted to know what different ways you could use to make this work. There we go. So let's just have a quick recap here. So we have a const int, which all we'll do is let us specify 3 inside here, and then we can use it here. This isn't entirely necessary, but it does clean up your code a little bit because it gives this number 3 a bit of a meaning. It says the amount of angles is our angle count. Having a 3 left over like this is what we call a magic number. They're quite bad because it hurts the readability of your code. People want to know what the 3 actually means. So if you bring in an angle count, then you can actually read, we want a set of angles and this is the amount that we need, and that's denoted by angle count. It adds text to a variable. It gives you a way of making sure that the text equivalent of a variable is present so someone can just read it. After we've created our integer, we can actually make a for loop that goes from 0 to the length, and then we ask the user to enter the angle. And in the previous example, we had enter angle 1, 2 and 3, so now we can mimic that by using I, but because I starts at 0, we want to use +1. Every time we loop around the for loop, we ask the user to enter the number, read it in through console readline, convert it using convert2 in 32, and then store it into the array. After this for loop is finished, we have all 3 values stored in the angles array, and then we have an int sum to count up all the values that we need. And then we use the for loop to go through every single integer value inside and make a running total and store it inside angle sum. Once angle sum has the total count, then what we can do is use console writeline along with a conditional operator to print whether it's valid or invalid to the screen. In this video, we're going to look at how we can use the built-in array functions to be able to sort an array. So if you have an int array called numbers, and then using the previous notation that we looked at, we can actually specify any numbers that we want using a comment delimited list. So if we just have 9 numbers inside here, then we've actually defined an integer array, and then the compiler can count the amount of items that are inside here and give it the length, but we don't have to worry about that ourselves. So if we use a for each, and we can just print int num inside numbers, we can do a console writeline on the new local variable called num. If we print it out, we can see all of the values, and maybe we can actually just use a console write followed by a space just to give them all on the same line. There we go. So as you saw before, if you had a string called test and we wanted to do something to it, for example, if we wanted to use the replace function, if we wanted to remove all spaces with an empty string, then if we check the replace tooltip, we can see that it returns a new string. Most of the string functions will return you back the new string after doing something with it. But in this case, if we type in array followed by .sort and we can place our array straight in the brackets, what you'll realize is if you hover over sort, it will sort the elements in the entire array, but it will indeed return back a void. And void just means it returns back nothing. So in this case, what it's doing is you're actually affecting the numbers array straight away, and you don't have to do numbers equals array.sort numbers. For example, if we were doing the test replace, we would have to do this, otherwise this would just be returning back a string, but we wouldn't be using it. The same is not true for the arrays. When you run the array functions, they tend to return back void, and you don't have to do anything other than give it the array that you want it to sort. So now if we run this code, you should just see the same output since they're already sorted anyway. So let's change some of these numbers up and just see what happens now. There we go. 0, 2, 5, 5, 6, 7, 8, 9, 9. And that's it sorted just like that. There isn't a whole lot to this sorting function, but what you should note is you can use this new array syntax to define how many items that you want in there instead of having to change the amount of positions that you have using the square brackets. You can just denote any number of items that you want inside The compiler will count them for you and place the length straight into the brackets for you so you don't have to worry about it. Using the array.sort function, all you have to do is give it the parameter of the array that you want to sort, and it will affect the array straight away and you don't have to restore it. And then we're just using a simple for each loop to print them out to the screen. In this video, I want to discuss the array reverse function. So if you had an int, numbers equal new int, and if you just had lots of numbers in here defined just up till 5, then we can add a semicolon. And again, using this array function, we can say array.reverse and pass our array inside. And then we can just use a for each var item inside our numbers and simply just print them out using a console.write. And we can use string interpolation and just put a space at the end. There we go. And if you run the code, then you can see our numbers have just been reversed. There isn't a lot to this video, I just wanted to show you about the different functions that you have available for arrays. These can come in handy when you have something like a list returned from a database, for example, and it's ordered in a certain way. And let's say you're returning back a list of lots of people who are ordered back alphabetically, and it's going from A to Z. And let's say you have some sort of user interface that allows you to flip the order. Instead of having to request the database to get the data back in the opposite order, you can use this array function to just reverse the list. The same thing goes if you're trying to order by lowest price or highest price, you can use this to show the different values in different orders. That's where this array function comes in handy when you have different situations like the names or the price by ascending or descending, where you can just flip the data instead of having to request it back from the database again. Flipping it locally is a lot easier than going back to the database, as that uses more data and more computational power on the back end and then return it to the front end. It's always best to be able to use these functions instead of having to use external things to be able to return back the same data. Using it locally like this will give us a performance advantage because it's done directly on the data instead of having to request everything again. If you wanted to do this manually, let's have a look and see what your options are. You can have your integer array just defined like this with a dynamic list, and then we can have a sorted array using the same length as the current array. And what you can do instead of using reverse, we can actually just comment these lines out. You can bring back a normal for loop, but if we use 2 r's, it gives us a reverse for loop. So the length is going to be our numbers.length, and the rest of the parameter is exactly the same. We want to go from the last -1 all the way till 0, and we want to decrement in 1. And we can say our sorted number I is equal to numbers I. But all this will do right now is just give us back the same value stored. So what we need to do in a case like this is make another variable, something like x, and we can store that into 0. And what we can say is x is assigned the value of whatever this numbers array is, because this is going backwards, but we want this one to go forwards, because we want it to be reversed, and we can say x++ and see what happens when we run it now. So nothing's going to come up because we don't have any output, so let's use a for each. We can have var number inside our sorted numbers, and we can just take this and place it in here and just print out the item, and we can use num. And there you go, it's been flipped. The exact same value is just the other way. So this is obviously a little bit more complicated because you have to use an additional variable, use a backwards for loop, and then increment your own separate variable, and as well as completely make a whole new array. Of course, you should only do this if you need it as 2 separate arrays. If not, you can always just affect the one that you're up to right now. Because I said before that arrays are actually static data and they're going to be fixed size, then there's no way to remove or add an item, but you can clear what you have already. So let's have a look. Array.clear sets a range of elements in an array to the default value of each element type. So the first parameter takes our array, so let's use numbers, and we want to start off at the index that we want to clear from, and let's just say 0. And because we want to clear the entire array, let's go all the way to numbers.length. And now let's just produce a for each var item inside numbers, and then just have a console write, string interpolation, which just prints out the item followed by a space. And now let's run the code and see what happens. So we have lots of zeros in the console, and this is to be expected because, as we've talked about before, the default value for an integer is indeed 0. So all this is doing when it says it's clearing, it's just actually assigning all of the positions the value of 0. And we can mimic this quite easily through a for loop. So if we comment this out and write ourselves a for loop, int I equals 0, and we want to go to numbers.length. And then simply inside, we just want to say numbers, square bracket I, equals to 0. What you can also write is the word default. This will pick up the default value for the data type that you specified. You can type in 0 or you can type in default, it's up to you, but I think in this case, if you're trying to reset it back to default, then you don't have to worry about remembering it or any typos, you can just use the keyword default. So if we run this code now, let's see what happens. So effectively, we've mimicked what this function is doing. But let's have a look and see what other parameters we have access to. So if we comment this out and drop the value, then you can still see we only have one constructor. Normally you'd see the up and down arrows on the left hand side to say one of two. In this case, we only have access to one constructor. It will only give us a range of elements we want to remove, but really we just want to clear. It does say here in the tooltip, the array whose elements need to be cleared. And because it is a clear and not a remove, you've got to remember when using this function, it doesn't actually remove any of the positions, it just resets the values inside the array. So what we can do in this case is we can say numbers, 5, 5. And what that will do is, the first parameter is where you want to start. So if you want to start at the 5th position, and then we want to count 5 forward. And because we have 10 numbers, then this should return back okay. Let's comment out this for loop so it doesn't take an effect, and let's run the code and see what happens now. So now we took the position 5, which is actually the 6th number because it's 0 base, and said we want to remove 5 forward, so itself and then 4 more forward. And there we go, we have 5 numbers being removed. So instead of removing all of the different values, we can actually clear a certain amount that we want, and to mimic this in a for loop, we can do the following. We can start it at 5, and we want to go to 10. And let's run the code, and you can see the output is exactly the same. When doing it in a for loop, you need to actually calculate what this is going to be. So we need to take both the numbers, the 5th index and the 5 length, which is 5 plus 5, and then we get 10. And we don't make this less than or equal to 10 because we have 10 numbers. So you actually want to go from position 5 to position 9, which will equate to less than 10. We actually want to go from position 5 all the way to position 9, which actually covers 5 numbers. 5, 6, 7, 8, 9. Even though it feels like the difference between the two numbers is only 4 because 9 minus 5 is 4, but we actually have 5 numbers between that. 1, 2, 3, 4, 5. There we go. So when we print the values from 5 till less than 10, we're going from 5 to 9, which is exactly what this is doing. This is the index that you start at, and this is how many numbers you want to count forward. So let's just have a quick recap of this function. We defined our numbers array. Using array.clear, it doesn't actually clear the values, it just gives us access to removing them back to their default values. It doesn't actually clear the array, it just resets the values back to their default type. We can have numbers parameter, which will equal to our array, and we want to say we want to go from index 0 all the way to numbers.length, which will be every single value inside the array. And all that will do is go through the array and set them all to their default value, which is similar to what this for loop is doing. And before we had int I equals 0, and I is less than numbers.length, and that will go through every single position. You can technically use 0 instead of default, but that would mean you have to remember the default value for every single data type. It's easier to just write the default keyword, and it doesn't promote any typos. Using the default keyword is by far the easiest and the most safest option if you're going to have this situation. So making every numbers index equal to default, in this case because we're using integers, it's going to assign the value of 0, and then after this for loop's run, with I is 0 and I is less than numbers.length, it's going to make all of these positions equal to 0, which is in essence what this function is here for. Because arrays can't be added or changed in terms of the values that they have after they've been created, you can only really modify what's already there, or you can reset them all back to 0. Using this notation from 0 to numbers length, you can get rid of all the values and make them all 0. Using 5 to 5 means it'll start index 5, which is the 6th position, and then go 5 numbers forward, so it will delete these and reset them back to 0. You can mimic this in a for loop just like this. Start int I at 5, and then go to less than 10. And the reason why it's less than 10 is 5 plus 5 gives you the 10th index, but because its I is less than 10, you actually want to go to the 9th index, because from 5 to 9, that's actually covering 5 different numbers. And then we can go through and assign the default value, and then when we print it out, you'll see that all of these numbers have turned into zeros, just like so. Searching through arrays are very helpful when you try to find some data inside your array and you want to return back the position to maybe do something else with it. So let's have a look at this example. So we have a numbers array, and let's say we want to search number 199 and find the index of it. So first let's ask the user what the number they want to search. Enter number to search, and then we can have int search is equal to convert to int32, and we're converting the console.readline. And then let's have a look at the function. So inside the array library, we have an index of. Searches for the specified object and returns the index of the first occurrence in a one-dimensional array. This is very important as it says the first occurrence, which means if there was another 199 at the end, it's only going to return you back this one and then stop immediately and not give you the value of this one. So let's have a look in the parameters and see what it takes. It takes our array and then a value. So our array is called numbers, and the value we want to search by is our variable called search. If you hover over the index function again, it says that it returns back an integer, zero-based index of the first occurrence of the value in the entire array, if it was found. Otherwise, the value is going to be -1. So we can say int position is equal to this. And because it says if it's going to be found, then it's going to have the value of a 0 index, and if it's not going to be found, it's going to have the value of -1. So we can say if the position is greater than -1, because if it's greater than -1, that means the value is 0 onwards. We can also write this by saying if the position is greater than or equal to 0, it's just up to you, they both mean the same thing. And then we can say in here, number search has been found at position. There we go. So let's run the code and let's do a perfect situation. So we can say 50, and you can see it says number 50 has been found at position 3, and that's the 4th index since it's 0 based. And what you could do if you wanted to is actually add 1 to this, just so it looks like a bit more of a readable number, because 4 is going to be the 4th number. 1, 2, 3, 4. And let's try find a number that hasn't came up, like 60, and it's going to return us back with nothing. This is really bad because it looks like the search has failed, which it has, but you need to output a message to let the user know. So have a console write line and say number search has not been found. Let's type that again, 60, number 60 has not been found. So let's see what we can do to be able to write this function ourselves. If we just block comment this for the time being, we can actually use int position equals to -1. And the reason why I make it equal to -1, because when we read the tooltip of this index function, it said if it's not going to be found, it's set to -1. So why don't we set it to -1 first, and then we can try and find it. So int I equals 0, and we want to go to numbers.length. And inside here, we want to scan each of the positions. So we can say numbers square bracket I, and if that is equal to our search, then we can set the position equal to I. If the number we're up to is equal to what the user has typed in, then we want to set our position to the index we're currently up to. And we don't need to have an else because we've already set it to -1. And after the for loop, we can actually take this if statement and put it back down here because the code's going to be the same. If the position is greater than -1, which in this case is our default value, so in essence, if this value has changed, then this should always pass, e.g. we've found the number. So let's run the code. And let's type a number in, 30, and now it's found at position 5, and now if we try 60 again, number 60 has not been found. There we go. So this function is exactly doing something similar to this. It's going through every single position, finding the variable, and if they match, assigning the index, and then after just returning back to position, back to the console. So let's comment our example, and let's see what other variants of the function we can use. And let's comment back the first one. So using this line, we can duplicate it and just comment it. So we have some other parameters inside here. If we add a comma, we can actually give it a start index. This is the starting index of the search. And let's say you only want to search from the second number onwards, then you can just type in the number 2. So now if we run the code and type in 90, it's going to say 90 is not found because 90 is the first one. And let's try a value like 50. Now it says the number 50 is being found at position 4, because now it's included in the range from 2 onwards. Because this is 2 onwards, it'll be position 2 until the end of the array. If you wanted a very specific range, then you can actually give it another value. So we can say we want to go from 0, and then we only want to go 2 forward. So if you run that now, and type in 22, it says it's not being found, because we've started here and we said 1, 2. So now it's only searching between 90 and 199. And if you wanted to include the middle ones, you could say you want to start at position 1 and go 2 forward, so now you get these 2 numbers and so on and so forth. So now if we try number 90, you'll see it's not being found because 90 is not one of these 2. The reason why you'd use different ones like this, if I revert back to the first one, this will go from 2 till the end, this will go a specific range, and this will go through everything. The reason why these exist is if you have a very, very big array, let's say it's 1,000 indexes, then you don't want to search everything unless you really need to. Let's say for example you had a names array and it was sorted alphabetically, and the person's name that you wanted to search began with an A. There is no point in running the search all the way from A to Z if you know it begins with A. And let's say for example you found the first index of the user that has a name B. So you have now the indexes from the start of the array up until the last array position that has the value of someone's name beginning with A. So now you have the 2 indexes of every single A name inside this array. If this was A, this was B, and this was C, and this was D, and you had these 2 positions, then you should only be searching all of the A names instead of searching the entire array. And the reason for that is you'll be searching lots more data for no apparent reason, and it's going to take an extra long time for searching something that you're never going to find. If you're searching for a name that begins with A, there is no point in searching for anything A, B, C, D, and so on and so forth. That's where you'd use the very specific range. You can say you want to go from 0 all the way up to the first B name, so then you're only searching the A names. This is just one example, and there is a lot more. Every situation is very unique, so use the parameters that you want, and always use the ones that can get you the best performance. The least amount of things that you can search is the best way forward. If you don't know what you're going to be searching, then you should always use the top one, which will just search everything. If you know where the value is going to be, or roughly going to be, then you can use this one or this one to give you a better range, and it's a bit more focused instead of searching for everything. So a quick recap of this index function, what it will do is it will return you back to position if it's found it. The position will be 0 based just as arrays are. If it hasn't found the position, then it's going to return this variable with -1. So therefore, after you've run the code, you can check if the value is greater than -1, which will be from 0 onwards. If the value position is 0 onwards, then you know that that number has been found, and you can use the position variable to output that to the screen. If the value position is -1, it means the array index function has returned back negative, and the value position is now -1, so you can output to the user that it has not been found. Just in my little explanation down below, you can see that we can mimic this function by setting the value of position to -1, using a for loop that goes from 0 to number's length, and if you wanted to as well, you could use these inside here. If you wanted to mimic this, this goes from 2 till the end, so you can say I equals 2 and you still want to go to the length. This one goes from 1 and then 2 ahead, so you can actually put I equals 1, and then because it's 2 ahead from 1, instead of numbers.length, it'll just be I is less than 3, because 1 plus 2 gives you the 3. So in order to do this manually, you can loop through the elements that you want, check if the number you're up to based off the index position of I is equal to the search variable that the user typed in up here, and if you find a match, then you can assign the position to the value of I. After the for loop is run, you can check the same if statement as we discussed above. These are copy and pasted down below just to give you an example in this little section. All these arrays have static data, which means that when you initialize them with a certain length, you can't increase that length or decrease the length, you can only modify the data inside it and you can't delete any rows. If you create an array of size 5 and you only store 3 people in, then now you have 2 positions that are being unused. and that's unnecessary amount of data stored in your memory if you're not going to be using it up. In certain situations, like when you're making a game, for example tic-tac-toe, then you know you're always going to need a 3x3 grid. So a 2D array will be perfect in this situation because you know the exact width and height of your array, so you can do this perfectly. Whereas lists are quite dynamic. If you don't know how many people are going to be within a system, for example, if you're signing up some sort of register for a class or for a school or something of the sort, and you don't know how many people are going to be in that class, then you can use something called a list. And lists are dynamic because what you do when you initialize it, you just say that you simply want a list. And you can add items and you can remove items and you can also modify them. If you wanted to expand the size of an array, it's slightly complicated, but it's not impossible. So if you add an int, numbers equals new int, and let's make that length 4. And let's say we had a numbers array that we wanted to increase the length 5. We could have a new numbers, change that position 5, and then what we're going to have to do is from position 0 all the way to 3, which is our 4th length, from the numbers array, we're going to have to copy that into 0 to 3 of the new numbers array, so now they have the extra data, plus the last one, which will give us our 4. So that'll be 5 length, 0 to 3 gives us our 4 numbers, and then we have one empty one. So we've just made a new array and then copied all the data from numbers into new numbers. Now of course this is not really practical, that if you want to reduce the size or increase the size, you're going to have to do this each time. Of course you don't want to do this, you just want to use something called a list. So let's stick with an example and see what we can do. So you make this length 3, and let's just put 3 numbers inside here. If you remember from the array video, we can also declare it like this. We can say numbers 0 equals 1, and then 1, and then 2, and change these values. These two are doing exactly the same thing. I'm initializing it with 1, 2, and 3, and also just saying that all the positions in here are equal to 1, 2, and 3. So we don't need these twice, but I was just showing you as a quick recap. So we're declaring an array, we're calling it numbers, and we're giving it a length of 3, and initializing it to 1, 2, and 3. Now let's see the syntax to define a list. You start off with the word list, and then you have a left and a right arrow which makes a little section. Inside the section you actually want to state the data type that you want. So if we're copying the numbers array, we can have an int inside here. And that's it for the declaration of the data type. And then we can say new numbers or list numbers equals to new, and then there you go, it gets auto-filled for you. But let's just type it in. We have list, open the arrow, int in the middle, and then close it. So now it's the same on both sides. But because this is a new, we need to add a constructor so we can open the curly braces. And the first constructor says, initialize a new instance of the list class that is empty and has the default initial capacity. Press the down arrow, we can give it a capacity of the number of elements that the new list can initially store, so we can start it off with 5 length or 3 length or whatever. It doesn't actually matter, it just means that we actually have 3 positions available immediately if we place 3 in the brackets. And the last one, we can actually give it an entire collection. So let's say if we loaded a list of numbers from a database or a list of something from a database, and we can actually insert it straight into this list by putting a list inside these brackets. Of course right now we don't have a list that we're going to assign it with, so let's just leave this empty and close the brackets and add a semicolon. So we could say list numbers dot add, and then we can add 1 and then duplicate this down and add 2 and add 3. So now these two have exactly the same contents. Instead of doing this, you can have the same notation like this. So you can have the curly braces in here, and we can put in 1, 2, and 3. Now that's doing exactly the same thing. And you see, I can just keep adding more numbers in here and the list simply doesn't care. But as soon as I add 1 more into here, then I'm going to get a syntax error because it complains that the length is not equal to the numbers that we have. Because the lists are really dynamic, it doesn't matter how many you put in here because it can just go on forever, of course until you run out of memory. So let's have a little working example just to see how this works. So we can have a for loop and we can go from 0 to 10 or maybe 0 to 3 just so we don't have to enter as many values. We can have a console write that kind of just says enter a number. And then let's read that in and we can say int num equals convert to int32 and we can place a console.readline inside here. And then after we've got the console read line, we've got an int num that's being converted from the console input inside our integer num. And from there, we can take our list numbers, .add, and we can add the num inside there. Or if you want to reduce a variable, you could just take this line and place it straight into here. Now if we get rid of that, when this for loop runs, we'll have 3 iterations. Let's run the code and find out. 1, 2, 3. So now we've entered 3 numbers and now they've been stored in the list. So let's create a for loop after, and we can go from 0 all the way to list numbers dot length. But of course, when we're using lists, we don't have a length anymore. When we're using arrays, we have length, because arrays have a fixed length, whereas lists have a count of the items inside it. So instead of .length, we simply use .count. And then inside here, we could just do what we normally do and say list numbers square bracket I. And let's run that, and we should see the numbers printed back out in the exact same order, 1, 2, and 3. And the same principle goes if you use a for each loop. We can say var item inside list numbers, and that's all you need to do, and you can just print item to the screen. Now we should see the same output twice. Let's have a look at other values that we have inside here. So we type in list numbers, dot, and let's have a look at the functions inside. So we can add, which we just used above, we can convert it to an array, we can remove a specific position, and we can clear it completely. They have other ones in here like binary searches. We can check if it contains a certain element. This is going to be very handy when we do our remove. We can convert them all to a different type. We have a copy to. We check if a value exists inside. We have a find, finding all of them. The difference between these two is the find will return back the first one, whereas find all will retrieve all the elements that match it. Finding the index of a specific match, finding the last index, iterating through them all. You can insert at a specific position, whereas the add will just insert at the end of the list. Adds an object to the end of the list. Inserts an element to the list at a specified index. And then you have remove, which gives you the first occurrence, so you could type the number straight into there. So you could ask the user, what number do you want to delete? And if they type 0, it will delete the first 0 in the list. And you can remove all, so if you want to remove every single 0 inside the list, you can do that as well. Or you can remove at a specific position. This is the most used function because what you can do is use the find index, search for an element that matches a condition, and then returns 0 based index of the first occurrence. So if you want to delete the number 0 from the list, you could use find index and that returns you back with an int, and then you can use the remove at and then pass that index straight into there. You can also sort it so it goes up in number order. We did this with the array.sort function as well. And if you wanted to, you can also reverse the entire list. This can be very helpful as we did with the array functions if you just wanted to reverse them all in case someone had something like a filter. When you're doing from price high to low and low to high, the difference between them two lists is simply the list flipped. So let's run a remove just inside here and let's see what happens. So we can say remove at and let's say position 0. So we type in 1, 2, and 3. You'll see that 1, 2, 3 gets printed out, and then I'll hit this remove at, and it will delete the first index. And in this case, the first index is going to be our number 1. So now this has become our first index, and this is our second index, and it's got rid of the number 1. So let's move on to a different data structure called dictionaries. Dictionaries are generic collections that store key value pairs in no particular order. They take in a T key and a T value, and these just mean the key and the value can be any data type that you want. Dictionaries come under the system.collections.generic namespace, and if you don't include this line at the top, then you'll have to type in system.collections.generic space dictionary every single time you want to specify dictionary. Putting the namespace at the top will include it within the project, and you can use dictionaries freely. So one thing to note is the keys must be unique and they cannot either be null. Values can be null or duplicate because they're the values depending on the key. As long as the keys aren't the same, then the values can be similar. So let's have a look and see what we can do. We can type in dictionary, and you can see it has the arrows either side, and you can see here it says T key and T value. And what T key and T value is it gives us the flexibility to add any data types that we want. We can add in 2 strings in here, for example, or we can do anything that we please. So in this example, I just want to store a list of names, and I want to give them a unique identifier. And this unique identifier will just give them a number that their profile is up against. It's the same way whenever you make an account with any sort of website, When your data gets stored in the database, you have a unique ID for your account. And this is the same thing that I'm trying to replicate here. We have a unique ID, and with that unique ID comes a name. So we can say equals new dictionary, just like we do with the list. We can end the brackets and end the semicolon there, and now we've created our dictionary. And the exact same principle we can use with the list. We can simply type in the name of the variable of the dictionary and type in .add, and then we have access to int key and string value. And this parameter is going to change if this now becomes a string, as I'll show you now. And if we reopen the bracket, you'll see this is turned into a string key. So that will change depending on the data types that you specified. So let's say we want to add 1 and we want to add ourselves. Then we can duplicate this down and add in 2 and 3. And we can say test and test. And now if we run the code, you'll see that we have no errors and nothing's going to show up. I'm just demonstrating that it compiles okay. And the same thing with the list, we can also simplify the initialization process and it looks something like this. So because this is a key value pair, we can no longer just type it in one line, they need to be in a little block. So when we wrap these around a curly brace, we can have the key on the left and the value on the right. And one of these is called a key value pair. Key value pair. And we will use these in the for each loop in a second when we print out all the values to the console. So let me just demonstrate something about what I said at the start. I said that all keys must be unique. And there's a reason why I said that. If we duplicate the first entry, therefore giving us the same key as 1, and we try run it, and let's see what happens, we get something called a runtime error. This runtime error happens when we run the program, and it's got nothing to do with compile time or our logic. An item with the same key has already been added. So we need to watch out if we do this because our program is going to compile, but it's not going to work at runtime. And let me demonstrate another fact. If we make this number 4, and our values are exactly the same, once we run this, it will still work fine. Values can be the same, but the keys cannot be the same. The keys have to be unique. So just like with our lists and our arrays, we can use a for each or a for loop to access this directly. So we can say for int I equals 0, and we want to go names.count. And the same reason it's a .count for a dictionary as it is for a list, but it's not for an array. Dictionaries don't have fixed lengths, and neither do lists. They are very dynamic and basically are a list. Lists can only store one different data type, whereas dictionaries give you a key and a value. So as we said above, we have a key value pair. So let's try and print this and see what happens. We can have a console write line and we can say names, square bracket I, and that'll give us back the position. The issue with this is it'll just give us back the string, and let's just see what happens if we print this. Then we get an exception because no key was given. And the problem with this situation is we can't use this like a list. Gets or sets the value associated with a specified key. What this means is when we give our square bracket I inside here, this is actually not talking about the index. This is actually trying to do a search on these keys. So if you actually change this to 1, then we should get ABBA return back. This is not actually doing an index lookup, it's doing a key lookup. And the reason for that is what we're going to have to do instead is say names.elementAt, and then what we can do inside there is place our index. So this element@at will return us back with a key value pair, as I said above here. So how this variable works is we can do key value pair, and then we need to specify this variable the same way we've got it up here. So we have an int, and inside a string, and then we can say pair, and make that equal to the function call element@, as that returns us back with a key value pair int string. And of course, if you wanted to make this a lot smaller, you could just simply use var, but let's keep it as key value pair just so you can understand what's going on. And the reason why we need to get the key value pair is if we want to retrieve the integer and we want to retrieve the string. And now we can use pair.key and pair.value. And because these are both integer and this one is a string, it matches our pair exactly. So we can take these values and go to our console write line, and we can say something like this. Use string interpolation and say pair.key, and then maybe add a hyphen, and then say pair.value, and then just remove these two lines. And let's try and run it now. There we go. So we get all the values, and it doesn't matter what this key is. It can be something random. It doesn't really make a difference. Like I said, this doesn't have to be in a specific order. So let's keep it as 1, 2, 3. There we go. So you can see using a for each loop to print this is a little bit more complicated. let's have a look and see what it takes when you use a for each loop. For each var item inside our names. And as you can see here, our item is automatically a key value pair of int and string. And again, what you can do is type this straight into here, just so you can get used to the notation. And there you go, it's still a key value pair. And then now what we can do is we can take this exact line and paste into here. And instead of pair, we have item. And this should return us back the exact same values. And if we just separate with the console write line, there we go. Okay, so now that we've understood this, let's take a look at an example. Let's comment this out, and let's create another dictionary. So we can say dictionary, and then we can have a string of string. And we can call this teachers equals new dictionary string of string again. And we can add our curly brace just so we can add our values straight into here. So as you said before, we need an open curly brace and a close curly brace. And then we can say the math teacher is called Aber. And then we can add another one. And we can say the science teacher is called test. There we go. So we've initialized our teachers, and we said that the value that we want to give it is a unique identifier, which is going to be our string assigned to the subject. And this is going to be the teacher that is assigned to the subject. So what we can do inside here is we can have a console write line, and we can do something like this. So remember when I was saying in the for loop, we can't actually use the square bracket notation like this, because this is inferring to a key rather than position. So we had to use element at just to find out the key value pair and then to print it out to the console. So because the square brackets is an actual search, let's try and make use of that now. So we know that there's a math class available, so we can type math in here, and what that should return us back is Aber. There we go. So what that's doing is it's searching through our dictionary, finding this element inside here, and then returning us back with the value for that key. Gets or sets the value associated with the specified key. The problem with using this approach is it says here, if the specified key is not found, an operation throws a key not found exception. Let's just say, for instance, I mistyped the math, and now we're just going to get a runtime error, and it's going to be a horrible exception, and our code is obviously going to break. This is similar to what we do when we have int.tryParse. We don't just try parse it immediately and convert it without actually checking if it's a valid value. So instead of doing this line, what we can do is we can check if that key exists first before we then use it. So we can say if teachers.try and get the value, which is similar to what we have with tryParse, and then the first parameter is the key that we want, which is going to be our math, and then out here is going to be the variable that we want to output out. So we can say out teacher, and then open the curly braces, and then inside here we can print out the teacher. So we try to get the value for math, and if we found that key inside these, then we return back the value inside our teacher, the same way it works for our tryParse. You take in a string in here, and the output is going to be an integer if it's successfully parsed it. And if it hasn't, we can say console output, math teacher, not found. So let's try and run that. Now you see we get returned back Aber, and if we actually drop the lowercase, then it says the math teacher is not found. Alternatively, what we can do inside here, let's assume that this is correct, we can take this value and place it straight inside the square brackets and do this again. This is kind of redundant because we've told it to get the value for key, place it inside teacher, and then we're just going back to the dictionary to get the value twice. So make sure if you have an output variable that you actually use it inside here. You can see that you're not using it when it goes a slightly dark color like this. So just like in the last examples when we were placing values inside our list, we can also do that in dictionaries. We can say teachers, square bracket math, and then we can make that equal to something. So if the math teacher were to change, and now the teacher is called Joe, then we can run this line and print out to the screen. Let's just take that for each loop and tailor it to the new dictionary and see what happens when we run it. So let's just change this into a var to make it simple, and then we can have teachers inside here. There we go. So now let's just run this. And you can see that now it says Aber as the first value. That Aber is coming from the console write line here that says teacher. This is one line before we change it, and we change the value of the math teacher to Joe on the next line, and there we go. It's committed the change. And just like in the last video as well, when we try to delete something from the list, let's see what we can do to delete it from here. So we can have teachers.remove, and you can see that it says key in there. And again, if we add the key in like this, then it's going to work just fine. There you go, we just have science, we don't have math anymore. but if I drop the lowercase, then it's going to cause us back with an error. But in this case, instead of it throwing an exception like it did when we were trying to do it up here and up here as well, the problem with using the remove is it just simply won't remove it. But what it will do is it'll give you back a boolean. And if you remember from the last video, we actually had a look at a section where in the list it gave you back a boolean whether the remove function worked or not. Alternatively, what you could do instead of using the remove function is to check if the item exists in the first place. We can say contains key, and we can place math inside here, and if it does contain it, then we can run the same line of code, and we can say remove, and then use math, just to make sure that this has been actually removed, and then in the else, we can say math not found. Retrieving values back should be retrieved using try get, just so you don't cause an exception if this is not found. We can simply do an update by placing the value of the key inside the square brackets and then simply just assigning it to something else. This assignment will change the value of the key which is inside the teacher's dictionary. And if you wanted to remove something, it's best to use the contains key just to check if it contains it first, and then you can do the remove, and then if it doesn't contain it, you can tell the user that math has not been found, and then finally we can just print it out like this. So in this exercise, I want you to create two lists with the integer data type, one for even and one for odd. And then we're going to loop through from 0 all the way till 20, and if the number is even, add it to the even, and if the number is odd, add it to the odd list. And at the end, print out all the values for even and for odd. I know you can just print these out inside the for loop, we don't have to have dedicated lists, but this is just for list practice, and I want to talk about different ways that we can do the solution. So let's start. We can have a list of int, and we can say odd, new list, int, and we don't know the size, so we're just going to leave the gaps empty. And if we duplicate this down, we can simply just change this to even. Now the reason why we're doing lists, we're going from 0 to 20. Of course, this 20 value could be anything, it could be 1,000,000, it could be 100, but we don't know. And the point is, lists have counts, whereas arrays have lengths. If we set the array length to something like 1,000, we know we'll probably be able to contain all the numbers inside there, but that's going to be a lot of positions that we don't exactly need. Because arrays are not really dynamic, because they're static, then it's best to use lists in this case, because we don't know how many numbers are going to be odd or are going to be even between this range. If we knew the exact number of positions that we needed in a given solution, then an array would be better since you don't want it to be dynamic if it doesn't need to be. So let's start. We can have a for loop that goes from 0 to 20, and if you want to include the 20 as well, we can just place an equals. The best way to determine if a number is odd or even is to use the modulus operator. So we can say I %2 equals 0. And what this will do is it'll tell us if I is divisible by 2 if the value is equal to 0. If you have 2 modulus 2, then the remainder is going to be 0. If you have 3 modulus 2, it's going to be 1 times by 2, which gets you to 2, and then to go from 2 to 3, you actually have 1. So if you insert an odd number and do a modulus 2, you're going to get a 1 returned. If you do an odd number and you do modulus 2, then you're going to get 1 returned. If you do an even number modulus 2, then you're going to get 0 returned. So what we can do in here is we can say even.add, and then we can simply add I. And then in the else, we can also simply just do odd.add, and then have I. Because the values of the remainder can only be 0 or 1, we don't need to have an else if in here. Doing this is a little bit redundant. Although it's still technically correct, the values can only ever be 0 or 1. So if we run this calculation and the value is 0, the only other value can possibly be is 1, so therefore we don't need this additional condition. And we can simply get rid of it. If I modulus 2 is equal to 0, then we add the number to even, and else we add it to odd. Normally when you have situations like this, we can use the conditional operator where we have the question mark followed by the colon. But in this case, we're actually doing two different assignments. We're either assigning into the even or assigning into the odd, so there's no room for the conditional operator. So at this point, we should have all the even and odd values from 0 all the way to 20 inside our two lists. So then we can now just print both the lists out. So we can say printing even numbers, and then we can have a for each loop that goes var item inside our even. And then we can do a console write, add some in-string interpolation, and then we can say item followed by a space. Then we can print environment.newline just to give it some space, and we can say printing odd numbers. Here we go. And then we can just take this exact for loop and copy it down. And instead of saying in even, we want to do in odd. And this is exactly the same since the variable name is exactly the same. Let's try run the code. There we go. It's got 0 all the way till 20. And you can see it goes up in 2s, hence our even numbers. And we also get these going up in 2s, except it starts from 1. And this covers all of the odd numbers. And if we change this number up to something like 50, then the list will just grow and our code should still work okay. You can see that all of these numbers are still consistently even. So now that our task is actually complete, let's just have a little recap. So the reason why we're using lists and we're not using arrays is for this exact nature. If we have 0 to 10, then we can almost work out how many even numbers and how many odd numbers we can have. We can manually count, we have 0, and then 2, 4, 6, 8, and 10. And then for odd, we have 1, 3, 5, 7, and 9. So we know how many numbers exist within here. But what if we just change that number to 50? Then now we have a lot more odd and a lot more even. It's impractical to type these numbers in and then to simply count them in your head and then make an array length based on that position. That's a bad solution because not all cases you're going to have the flexibility of simply typing in the numbers like this and counting them yourself. These numbers could be something that are typed in by a user or something loaded for something external like a text file. You need to understand that these values can be generated from anywhere, and if you just type them in, then it provides an unrealistic expectation of how to write some programs. So what you have to bear in mind in situations like this is you simply don't know how many even and how many odd numbers will be appearing during this range. So you want to use a list so it's as dynamic as possible. We have two lists in this case, one to store all the odd numbers and one to store all the even numbers. We don't initialize them with any sort of capacity, we just keep it empty for the exact reason we don't use an array. We loop through from 0 to anything. We don't even have to loop from 0, we can also just start this at 100 and go all the way till 1000. It really doesn't matter what our number range is, the only thing that matters is that we have in a list that is going to be dynamic and then we can calculate whether that number is odd or even and add it to the right list. How this works is we use I, which is the number we're currently up to, and we calculate the modulus of it to check the remainder. If the remainder is 0, then it must be even, as it's divisible by 2, and if it's anything else than 0, which it can only ever be 1 in this case when using modulus 2, then we add it to the odd list. After this for loop is run, now our odd and even lists have all the values that they should have, and we simply just write these two blocks are exactly the same, just print the even numbers and print them out, print the odd numbers and simply print them out to the screen, and that's it. And if you run the code, it might get a little bit crazy in here, but as you can see, these will actually work. If you pick any random numbers, you can see that they're all divisible by 2. And the same thing goes for odd, you can see that they're not divisible by 2 because they're all odd. So in this exercise, we're going to cover a little task. I like to call this task an array of multiples. So we want to define and initialize two integers, a num and a length. So in the case of this example, we have a number 7 and the length of 5. So what this will do is it will essentially give you the 7 times table, but only the first 5 numbers, 7, 14, 21, 28, and 35. We take the first number, which is num, which will give us the multiples, and we take the second number, which is the length, and that gives us the size of the array. So we create the integer array with the size of length, we loop through the array and insert the loop counter times by num, because this is 1 times 7, 2 times 7, and so on and so forth, until we reach the length and we place it into the array. And then finally, we print the array just to give us these values out to the console. Alright, so let's get started. We can have it int num, and we make it equal to 7. We have it int length, and make that one equal to 5. Now that we defined and initialized the two integers, let's create the int array with the size length, int array, result equals new int, and we want size length. After that, we want to create our for loop. Now this is the tricky part. If we try go from 0 all the way to result.length, then let's see what happens. So we want to start result I, we want to make that equal to number, which is our array of multiples, times by the value that we're currently up to. Now let's print our array using for each loop to see the value. So we can say var item inside our result, and then we can have a console write that just prints one of them at a time. So we can say item followed by a space. Now let's see what happens when we run it. So we get 0, 14, 21, and 28. And as you can see, these are the first 4 numbers. So we're close, but we're nearly there. Because our array starts at 0 and it goes to the length, which in this case is going to be 0 to less than 5, which will cover the positions of 0 to 4. With these positions, it's going to do 0 times 7, 1 times 7, and then get to 4 times 7, and not actually get to the 5th because we're starting from 0. So alternatively, what we can do, or what you think you can do, is change this to a 1 and change this to equal to. So now what it's doing is it's going from 1 all the way to 5, which is still covering the same amount of positions, it's just one index forward. So now if we try to run the code, then we get a runtime exception. And the reason for that is it's trying to access position number 5. If we hover over I, we have 5, and if we hover over the result, we actually have some of the right values. Except it's trying to get to the 5th position and it's not working. The reason why the 0th index is actually 0 is simply because that's the same value as the default value. Because our for loop started at int I, it's actually only starting from here and going down. So this calculation is actually correct, but it needs to be back 1. We need to start the multiplication on I equals 0, but our for loop needs to start on I equals 1 so we can get all the way through. So we have two ways of doing this. We could say I minus 1, so even though it goes from 1 to 5, it's still assigning it into the array using 0 to 4. So if we run that, we can see that that'll give us the desired result. Alternatively, what we can actually do, instead of doing I minus 1 inside here, we can define a variable called counter and make it equal to 0. We can change this to counter, and we don't need to change multiplication because that's already going from 1 to the length, which is 1 to 5 in this case. After the for loop is run, we need to remember to increment counter. So there we go, we have the desired effect. Another hack if you're interested, if you have two variables that you want to increment inside the for loop, you can see that we already have I++ in here, which will increment it by 1. And we want to increment counter by 1 as well every single time it loops around. What you can actually do is remove this, and you know how these are broken up by semicolons, that indicates that the section has ended. The first section is for declaration, the second is for the range, and the third is so you can increment the variable or decrement it. When you're trying to increment two variables inside a for loop, instead of placing a semicolon here and type in the next one, you can actually place a comma and do counter ++. What that will tell the for loop is every single time you go through, you want to do a series of these actions. And because we have I++ and counter ++, then that's going to work exactly the same way. It just prevents us having counter ++ down here, and we can move it inside the for loop just so it does it for us, and it looks a lot cleaner because you can clearly see that every single time we loop around this for loop, we're going to increment these two variables. There we go. So let's try put some different values in here, maybe make this 10, and we can have 10 on both, so it should give us the first 10 numbers. There we go, from 10 all the way till 100. Let's have a little recap. So we're essentially just making an array that will give us back all the multiples, so it's like a mini times table. But the fact that we're doing it dynamically using our array is quite important. What you can do if you wanted to is to extend this program, you can ask the user to type these into the console and then convert them and use them. Right now we're just statically typing them in, and that's not really an issue since the main focus was doing this for loop. If you wanted to, you could ask the user and you can type these values in so you don't have to change them every single time you compile. So now we've got the number and the length, let's make our int array called result and initialize it to the length. We set up this counter so we simply didn't have to do I minus 1 here, so it looks a little bit more intuitive. We start the for loop from 1 and go to the length so we can access 1 to 5. And the reason why we want to do 1 to 5, so when we do our multiplication it doesn't start at 0. These two are going through the exact same amount of indexes. 1 to 5 is 5 numbers and 0 to 4 is also 5 numbers. So when we do our multiplication we want to start from 1 since the timetable normally starts at 1 and we go to the length. The reason why we're using the counter is so we don't have to do I minus 1 in here, and it breaks up the logic a little bit and it looks nicer without counter. We start our counter at 0, and instead of incrementing it down here, we use this fancy comma and we can say we want to increment I and counter every time the for loop goes around. So we don't need to include the counter increment inside the for loop. And this one line is pretty simple. We say result, the index of counter, which will start at 0, which is the start of the array since it's 0 base, and we say that's equal to the number, and the number is going to be a fixed number since this is the multiple. And we say number times by I, and in this case it goes from 1 all the way till the length, so we get essentially the times table. And at the end we just use a simple for each loop that will go through all the items inside the result array and just print them out to the screen with a comma after each other using console.write just so they're all on one line. This is the start of the function section. Functions can also be called method, they are used interchangeably. In the introduction, we discussed dry, which means don't repeat yourself, and the whole point of dry is so you don't have multiple sections of code that do basically the same thing. You want to wrap it around in a function. Functions are used to improve the readability of your code and the reusability of the code as well. Having multiple section code that are basically exactly the same can be more prone to errors. If you wrap them around and place it in one singular function, you can make sure that they're error prone, and then wherever you use it, it will be error prone as well. If you have to copy and paste and tweak some code, then you're actually exaggerating the amount of errors that could occur. And plus, it makes your code look a lot cleaner and the structure is a lot better since you can name the functions. So let's take a little example. We have a static void main straight into here. This is a function or a method, and these are the parameters for the function. The .NET framework expects every C# program to have a main function with a capital M, and it needs to be a static and a void. The parameters don't exactly matter, we can also remove them and it won't be a problem. The only thing that matters is this needs to be called main. If we drop the lowercase on it and try and run the code, then we're going to get a build error. Program does not contain a static main method suitable for an entry point. So if we change this back to M and run it again, and then it works fine. So that's one thing to note about the .NET framework, is you need to include the main function, otherwise the program won't run and it won't even compile. So let's take a look at how we can use this. We can have something like a console write line and we can say welcome to my program. This is a line that we're probably only going to use once, but let's say this was welcome in someone's name. Welcome Abba. Let's say you had this in your software in many different places. You don't want to be recalling this or retyping out this message in case you type it wrong the 5th time and you get an error. Of course, this won't be a syntax or a runtime error, it'll just simply be a logic error because it's a typo. So in order to make sure this typo never occurs, we can actually make another function. So outside of these curly braces and just still within the class, we want to create a new function. So we want to follow this exact same approach. We can say static, then void, and we can call it welcome message. And we don't need to give it any parameters because we're not really going to give it any values just for now. Now that we've made that, we have no syntax errors and we can run it like this. Except of course there's no body, so let's place our console write line within here. Now if you run the code, nothing is going to happen. And the reason for that is, the code will still execute in the main. We haven't called this function inside the main. We've defined it and called it welcome message, and we've gave it the contents, but we haven't actually made use of it. And you can see that when it's highlighted in a darker color. That means it's not being used. As it says here, private member welcome message is unused. So now we can simply type in here, welcome message, followed by an open bracket and then a close bracket to denote the parameters that we're going to give it. And of course, in this case, there is no parameters. And then we close the bracket and add a semicolon. Now, if you run the code, you can see it says welcome Abba. So just to go over some of these words that we're using. Static means that we can access it anywhere and everywhere. What I mean by that is, we don't have the keyword new just before this. We don't need to make a new instance of the program class in order to access this. So what that means is, when we make future programs, we're going to have some functions inside our class. Inside the class, you can actually denote if a function is going to be static or it's not going to be static. You don't have to specify is it static, but this won't let you call it from here because it's unaware where this function is coming from. An object reference is required for the non-static field, method, or property. Because this is static, you need to reference something else from a static nature. All static means is you don't have to create a new instance of this thing in order to use it. We'll see different examples in the future where you have to create an instance in order to use something. So let me just show you quickly. If we have a test and I say static void something, and we can just print out nothing to the screen, and let's try and use this. So because this class is outside of the program, we have to use the notation test dot, and then it should be available within here. And the reason why it's not is because we need to insert this public word just before it. And public means everything has access to it, and static means you don't need to create an instance. Now if I type in the dot again, you can see we can now see something. And the reason why we can see something is because this is a static. Now if I remove the static word, then you see that we'll get a compiler error because it doesn't know where this is. Now if you don't use static, you need to do this. You need to say test equals new test, so we make an instance of the class, and then inside test, then we get the something. So that's the difference between static and not static. Essentially, it's accessible from everywhere, but if you don't want to be accessible from everywhere, then you can just simply remove the static word and the user will have to create a new instance before they can use it. So this is what it's like without static, and this is what it's like with static. Don't worry if you don't understand this too much, this was just a quick overview, but I have a dedicated video later on in the course, so don't worry too much about it. So now that we've made a function and we've called it successfully in the main, and it's printed out to the console, so when we're declaring functions, we want to specify what return type we're going to have. We have a static void main in here. If you hover over main, it says void, which means at the end of this function, it doesn't return anything, hence it's void. If you have a look at something like an int.tryParse, and we open the brackets, you can see that it takes in a string and it takes in an integer out parameter. It also returns us back with a boolean. So we can have something like 123 out int result, and then it doesn't actually complain about anything. But what we can do is also just store this in to a bool success and then print it out to the screen. There we go. So it says it was successfully true. If we remove this, or whether we keep it in or not, the tryParse function doesn't actually complain, but the main point here is it defines back a bool. That means at the end of this function, it will always return you back with a bool, and it's up to you if you want to make use of it. And you can alternatively, you can place this straight inside the console write line and get the value printed straight to the screen, or you could wrap this around inside an if statement like we've done in the past, etc., and make use of it that way and have the result being printed out inside here. The point is you have functions that return something and functions that don't. If you remember that we had the array.copy, for example, you'll see that they have void here because they just apply a function to something but they don't actually give you something back. This is the difference of having something like this, a string test that says hello, and then you can do test.replace, and then you can return you back with a string, and it says here it returns a new string. Whereas when we had a string builder, for example, and we did string builder.replace, you can see that although it does say it replaces a new string builder, you can type anything inside here, and it will still affect the current string builder. It won't have to do sb equals sb replace as you would need to do here, because this returns you back with a new string. And if you wanted to replace test, you would literally have to say test equals test.replace. With something like a string builder or the array functions, you don't actually have to do any of that. So you can say array.empty and it will just return the empty array. And the ones that we used before are things like equals, and that will give you back a bool because that's determinate whether it's equal or not. But if you're doing functions like sort, for example, and doing things like reverse, it just simply applies the data, but it doesn't return you back with anything. So you can literally just call it inside here, put your array in the brackets, and it'll use it happily. Now, depending on your user case, you need to define whether or not you need to use a return type or not. For now, let's just cover void, which means it won't do anything. So let's just define a function. Static void, create and print an array. Open the brackets, close the brackets, and we can have it int numbers, make it equal to new int with length 3, and then just have 0, 1, and 2 inside here as the initializer. Let's just do a for each var item inside numbers, and then just do a console write string interpolation and just have item followed by a space. And now that it's dark grey because we haven't called the function, so let's make use of it at the top of our code and let's run it. Now you can see we get 0, 1, 2 printed to the screen, and if we make this into a 5 and simply just add more values in here, and then we run the code, you'll see that now it'll update. But because this doesn't return us back with anything, and we don't actually use the integer array outside of these curly braces, it's not actually available up here. Numbers won't be accessible inside here because it's simply not within the scope. Numbers is only available within this curly brace and this curly brace, which means when this function finishes, numbers has now been deleted from memory, so you can't access it after this line. Void doesn't do anything. It simply just does the contents of the function, and as soon as it reaches the bottom, that's all that happens. You can have another function defined that can return a value, like I said with int.tryParse, for example. At the end of the function, you'll see a word that says something like this. It will have return and then return back something, followed by a semicolon, and that will dictate that as soon as that function is done, it's going to give you something back. Now we're going to cover that in the next video, but for now we're only going to cover void functions. So we can have something more obvious like a static void, welcome message, and simply just do a console write line, welcome to my program. And we don't need to return anything here because all this function will do is simply print out a welcome to the screen, and we can use that just before the print array. So we can say welcome message, open bracket, close bracket, and then a semicolon, and hit F5 to run, and there we go. As you can see, our main is really tidy now. It gives us function names that tells us exactly what's going on. We're creating and printing an array, and then welcoming the user to the console, and then having a console read line at the end. There isn't an awful lot to void functions. All you need to know is that when you create a function, you need to give it a return type. It returns back a certain data type, or it simply just doesn't. And depending on what you want to do and what you want to achieve with that function, really depends on if you want to return a data type or not. In the case of these, since they're just doing something and then moving on, you don't actually need to return anything by it. With int.tryParse, you want to make the function is executed successfully, so when you use int.tryParse, you can see that it returns back a bool, and the bool determines whether the conversion has been successful. And based on that return value, you can determine the next steps of your program. If all your function needs to do is provide some sort of functionality and then quit, then that's fine and a void is fine. But if you need to provide some functionality and then also return a value, then you'll need to specify the data type in here, which we'll cover in the next video. So far we've covered void functions, but we haven't covered return types. Void functions are where the function just does something but doesn't actually return anything, hence the name void. Let's start with an example. If you have a static void, print introduction, you might want to just return back your name. After you've printed this line, it's going to print it to the console, and that's all it's going to do. There we go. Let's say there's a situation where you actually want to use this inside your code. You can actually set the console's title by typing in console.title and type in your name inside the quotation marks, or you can type in anything inside here. If you run that, you'll see Abba is in the title of the console right now, and that looks pretty cool. But you got to realize is now we have two references to the same value. Now at this point we can actually do something better. We can type in static string name equals Abba, and then instead of using Abba in here, we can say name, and instead of using Abba in here, we can also say name. And they're both using this variable, and if you run the code now, you see that the same output will happen. You have Abba twice, both in the title and both in the console output. Now the problem with this approach is you're actually making use of a global variable, which we do not like in code. In situations like this, you shouldn't need to make a global variable because there are ways around it. So instead of having this, which has a print introduction, and we've got the name used in there, but the name is coming from here, maybe we can use this somewhere else. So let's say we make another function called static, and instead of void, we want to actually return back a string. So we can say string, and then we can say my name, or something like return name, or anything you want. Just make sure you give it a meaningful name so it dictates what the function is trying to do. So if this is to return the name, and the reason why there's a red underline is it says that not all call paths return a value, since we need to use our keyword return. Now that we add some empty quotes on the return, it's going to execute fine and the compiler error is gone. So obviously we don't want to just return nothing, we actually want to take this Abba and return it in here. So let's get rid of our global variable and let's see what we're going to break. So we're going to break these two references to the name variable. And simply inside here, we can actually just call return name. And then here as well, we can call return name. And what this will do is inside here, it will execute this function and then return the value in here. If this is too many steps for you, you can have a string name equals return name, and then simply use the name inside the brackets. These two lines are doing exactly the same thing, except this is using a variable because we're storing it first and then we're using it. Whereas if you place it straight inside the brackets, that's just going to store it and use it immediately, and there's no additional variable. But don't worry too much if you're going to do this notation, because an extra variable in this case doesn't really matter, because as soon as this function is executed, the variable used to run this function gets deleted since it's inside the scope of these two curly braces. So now if you run the code, you'll see that again we have Abba and Abba, but now what we've done is actually controlled everything throughout here. So if your name were to change, or maybe this changes in a different circumstance based on the user that's logged in, then you can simply have the same thing now printed in two different locations, in the title and in the console output, and it's actually coming from one function. So we can have a return name, and we can make a static int now, and we can say return age. And then we can have simply return 23, and that's our name and our age being returned. That changes back to Abba, and then instead of the print introduction, maybe we actually want to print a little bit more than the name. And maybe in the title, what we can do is have string interpolation, wrap the return name, and maybe put a hyphen in there, and then we can say return age. So if we run the code now, you can see we have ABBA-23. So maybe that's the title of our console, but then in the introduction, we can use a bit more than that. So we can have int age equals return age, and then in the console output, we can have something like this. Hello, my name is name, and my age is age. And then after we've compiled that together, we can place the output inside here. There we go. So we're using the name and the age inside the console title, and then we have this function that runs to get us back the name and the age, and then we're using it using string interpolation. Of course, these 4 lines can be all squished into one. You can simply take this $sign. Let me duplicate this line. You can take this and paste it straight into here, and where you have name, we can have our return name, and where you have age, you can have return age. And that will actually rule out all of these lines, and you can wrap it all into one. There you go. And if age were to change, like I said before, you can simply type this number in, change it, and you can see in both cases in the title and in the console output it has officially changed. Functions can be very helpful to reduce repetition in code. Let's show you an example. If you had 3 sections where you said enter a number, and you had int num1 equals convert to int32, and then we had a console.readline, and then you had this section and you wanted to do num2, and you had this section again and you actually wanted to do num3. Now at this point, even though these 3 are actually identical, you want to be using an array in this case. So you could have int numbers equals new int square bracket 3, and then in here we could say numbers 0, numbers 1, numbers 2, and then we don't need the ints because it's already been defined, and then we have them like this. But because again all of these 3 sections are exactly identical, we can actually run a for loop that goes from numbers.length, and then we can place one of these straight inside here and then change this to I. And now we've achieved exactly the same thing, but we're not actually done yet. So if you run the code and we do 1, 2, 3, now we've stored all 3 numbers. So we have enter a number, and then we have the console read line. And maybe we can actually make these 2 lines a little bit shorter. So let's make a function, static, and because we essentially want to return an integer, we can say static int read number from console. And then if we take these 2 lines, place them inside here, and because we need to return back an integer, this is the value that we're going to be returning. So instead of assigning this position to something, we'll actually just immediately return at this point. So instead of doing this line now, and instead of doing all of this, we can simply make this into one line of code. Read number from console. So every time this will execute, it will jump into here, print out the value, enter a number, the user will type it in, it will read it in, convert it to an integer 32, and this will return back the integer that the user's typed in, and then that will return it back to the console and essentially replace this. So if the user's typed in 5, then it essentially replaces this with 5, store it, loop around, and if they placed in 10 the next time, and then you replace this with 10 essentially, and then that gets stored inside, and so on and so forth, until all the positions have been complete. Let's test that. 1, 2, 3, and it still works okay. Of course, I'm not actually printing the values out to the screen, so if you wanted to see that quickly, for each, we can have var item inside our numbers, and then do a console write with some string interpolation, item followed by a space, and let's run that 1, 2, and 3, and there we go, we get 1, 2, and 3. Of course, you can make these functions and they can return any bits of data that you want. You can even have something like an int array, and we can say create random array, and then we can create an array called numbers, make that equal to new int square bracket 3, and we can actually give it the values of 0, 1, and 2, and then just at the end here we can actually just return numbers. And then just in here we can have an int array, and we can call that new numbers since we have numbers above, just above here, and then we can make that equal to create random array. And because this returns us back with an integer array, then there's no compiler errors inside here, and we can have a for each, follows the exact same approach as the one above, new numbers, console write line, into a console write, and then have item followed by a space. Now if we print these both out, you can see that the 0, 1, and 2 actually comes from the new one. It's just we have 2 console writes right next to each other, so there's no new line separating them. So if we just add a console write line here, 1, 2, and 3, and there you go. 1, 2, and 3 comes from the 3 inputs we just typed in, and 0, 1, and 2 actually come from the function that we've just created. Of course, if you don't like this notation, then what you can do is you make it a lot easier. You don't even need to make a new variable, you can actually just return the integer just like this. So if we place this straight inside here, actually just make it on one line just so it looks a bit neater, then there you go. We have our entire function reduced to one line. The goal of functions is to make them do as little as possible. If your function has two different things it's doing, or more, then you should break that out into another function. For example, if you had a function that did two distinct operations, one was a conversion and one was a calculation, then you want to split that out into two. The first function should be the conversion, and the second function should be the calculation. And the reason why they're separate is because if you want to reuse them as a pair, then you won't be able to reuse each of the pairs. If you wanted to have a calculation on its own, then you can't do that if both functions do the same thing. For example, you could have a static, and it just could be something, let's just call it void, and it could just be test, for example. And if you had the conversion here, and then if you had the calculation in here, then you need to split this up into two different functions. You want to have static void conversion, and static void calculation. If you wanted to use conversion or calculation separately, you can't because now it's in this pair together. So if you wanted to use them separately, you simply can't. It's best to keep functions on their own anyway, just so they have a single purpose so you can give them a name. Because as you can see here, we can't give this an appropriate name because it's doing more than one task. This is doing the conversion, this is doing the calculation, and this is doing multiple things. This could be doing something. If you have to think too hard about the function title, then you might be doing too much within each of the functions. These are very easy to be able to decide what they do, because this one converts and this one's going to calculate. Reading number from console. If this was reading the number from the console and doing something else, then it's going to be a bit of a problem because now you've got a bigger name. You don't want to be doing reading number from console and something else, because then your function name gets also too big and you've got multiple dependencies. So the best thing to do is to call them accordingly and keep them as short as possible. So let's say we wanted to make a function that added two values up. We can have a static int, call it add, and then we can return 5 plus 5. Now this function is a little bit redundant, although it will actually work. So if we go back to our main and we do a console write line and actually print the value of add, and we go through our function, then we see we get the value of 10, which is indeed 5 plus 5. But since this 5 plus 5 won't change, it's always going to be 5 plus 5, this is where parameters will come in, which we'll cover in the next videos. Parameters are a way of being able to give the function value, so these two can be actually changed. There's no point in having an add function if the only ability you can do is add 5 plus 5, because you may as well just return 10 at this point. So I covered a lot in this video, and there's lots of different functions that do different things. Of course, there is quite a lot of lines, we're up to 87. This is probably the biggest project that we've wrote so far, and even though this is not really a project, it's just a bunch of functions that do little things that are made for demonstrations. So let's have a recap. So first here, we're setting the title as a result of return name and return age. We can actually take this and develop this further if you want to. We could actually say return name age pair. And if you wanted to collapse that inside one function, then that could be really easy. You could say static string return name age pair. And then you can have return, and literally the exact same line above, you can have return name, followed by a hyphen, and then you can have a return age, and then end the line like that. So that just concatenates the two values that are returned from these two functions, but the point is you keep them all separate. If you were to type in very statically inside here, ABBA25, then obviously like I've talked about above, then you're going to have duplication of data, and of course we're going to use this name inside something like here. And as you can see, this name age pair is actually not applicable when it comes back to this format, so it's always best to keep these two separately. So if you bring it back and we can actually keep it like this, now instead of having this code, we can actually say return name age pair. That will give us the same value at the top of the code. It will have ABBA-25. So that's that bit. In our print introduction, if we hold Control and we actually press on this function, it will actually jump us right down. And then if we press the back arrow top left, we can go back to it. There we go. And then click forward. So in this function, we can break down all of the return values into string variables. We have a string name equals return name, and int age equals return age. And then we have a string input that concatenates them both together. Hello, my name is name, and my age is age. And then we print out to the screen. Or if you wanted to, we could wrap all four of these lines straight up into one. We don't need to assign these into variables, although it does help the readability if you keep them separate, but I prefer to keep it like this since I'm used to this notation. We can place return name straight into there, which will get rid of our name variable, and the same thing with age, which will get rid of these two variables. And of course, we're actually storing the string value before we're printing it, so we could just take all of this and place it straight instead of here. Scrolling back to the top, this little section was demonstrating how we can use integer arrays to read in all the values from the console, but wrap it around in a function. So before in here, you would have something like a console write line, you'd print out the value to the screen that would say something like 8 to a number, and then you have on the next line a convert to int32, and then after you converted it into 32, you'll actually store it straight into numbers. But because this is going to be the same thing for inserting all the numbers, you can actually wrap this around in a function. So if we hold Control again and go to this, you'll see that them two lines are very simply placed in here. Console write line, enter a new number, and then a convert in 32 based on the console read line, and then we're simply just returning that back, ready to be stored in the index of the numbers array, and then straight after that we're just printing out all the values to make sure it's worked, and that all succeeded fine. Here I was just demonstrating that you can have different return values and it can literally be anything. So as you can see here, if you hover over create random array, it's inside the program class, it's called create random array, and it returns back an integer array, so that's what we're signed into. And if we hold Control and click on this again, you can see that all this simply does is returns us back a 3 length array with 0, 1 and 2 as the array positions. And then if we scroll back up, when we execute this for each loop, then we're simply going to get 0, 1 and 2, just like that, since it's a console write and it'll be on the same line with a space after each other. This demonstration was slightly theoretical. I was saying in one given situation, a function should only do one task. If your function converts and does a calculation at the same time, then these are actually two different things. You should split them, so you use the conversion in this step and you use the calculation in this step. If you wanted to convert something or calculate something in the future, then you can only do it now because we've separated them. Whereas before, if you have them both inside here, then you simply can't do one operation because you've wrapped it around in one section. The same is true when I was discussing this earlier on. If we kept this name pair as the only way to access the age in the name, then it's going to mess up when we use it in here, and then we're going to have a duplication of data. But because we separated the name and we separated the age, we can use it in this function and we can use it in this function, and it doesn't interrupt anything. This simply returns the name, this simply returns the age, and these two functions make use of them. If we had something else underneath, there was another function that depended on the name and the age, then again we can simply use them. If it was restricted to this function, then it's going to be a problem using it in this function or any future ones. And finally, just to finish off, add function, and all it simply does is return 5 plus 5. And I was saying as of right now, even though it returns back a value, it's kind of pointless, because you may as well just return back 10 since it's doing the same thing. The reason why I included this function is that we can set it up and start planting the seeds to understand why functions exist and how to make use of parameters. What a parameter is it lets you put things within these brackets so you can give this function some data. So if you have an int.tryParse, for example, these things that we place inside the brackets are actually the parameters. So we have a string s and an out int something. And that's how the parameters work on our tryParse function. And just to show you, this is how it's actually wrote. It's a bool, and then it's called tryParse, and it takes in a string s and an out int result. Then we can make this static, and I know it's because it gives us an error because we don't have the control path. If we just use result and assign it to 0 and then return back true, you can see that the compiler error is now gone. And as you can see here, it says bool tryParse string s out in result. And if we actually try and use the tryParse in here and press the brackets, you can see that these parameters are exactly identical to parameters that were inside of the tryParse coming from the integer library. So in the future, we're going to study how we can use parameters to pass data inside our function. But just for now, know that this function is essentially pointless because it's only going to return back 10. And this function will gain the functionality it needs when we start adding parameters. This should essentially be add 5 plus 5, except this is kind of a pointless function because we already know the value is going to be 10. But again, this is just helping you understand why parameters are very essential to functions. We've covered how to create a void function and a function that returns a data type, but now we want to create a function that gives it some sort of data. You may not realize it, but all these functions that you normally use, like console write line, you're actually inserting data consistently into all of these functions. If you hover over console write line, you see it says void console write line, and right now there's an open bracket and there's a close bracket. If we delete this bracket and reopen it, you see there's 19 different ways that you can call this function. And as soon as you start to type a string, you can see we have a string format and an object if you need to. And if you type in another string, you can see it says string value. This string value is actually a parameter. If we hold Control and press on write line, you can see all of the different functions right here. This is the most basic version that just inserts a write line character to the console, and then these are all the different parameters that you can give the value. Of course, you can't double click and view the source code because this is hidden inside Microsoft's libraries. The values that are placed inside these parentheses are actually called the parameters. This is known as functional overloading, which we'll cover later on in the course. Basically, that means you can have the same name function but give it different parameters, and you'll see why this is helpful later on down the line. So let's close this tab in the top right hand corner and let's bring back our code. So now that we've passed hello into this function, that's us actually giving this a string value parameter, and that hello is going to get passed straight into the console write line, so then when we run the code, it's going to print it to the console. So let's create our own function with our own parameters. So if you take the function I had last time, it was static int add, open bracket, close bracket, and it simply returned 5 plus 5, which we all know is going to be 10. So if we place add inside these brackets, and we run the code, we should get 10 returned back. There we go. So of course this is a little bit pointless since it's always going to be adding 5 plus 5. There is no way we can change this without the use of parameters. So in here we can actually just do what we do when we normally declare a variable. We say the data type int and then the variable name, and then if you want to add multiple parameters you can simply add a comma. So now we can say int a and int b, and you can see now we've got a syntax error because it expects us to have both of these values inside. If you hover over it, there is no argument given that corresponds to the required formal parameter a, and then if we insert a by having 5 for example, and if you hover over it, it complains about not having b, so we can do comma and then do 5 again. So just this on its own is not actually going to do anything. We're actually giving the add function the values of 5 and 5 and placing them inside a and inside b variables. These are now known as local variables, and they only exist in memory between these two curly braces. As soon as this function is done, these are deleted from memory and you can no longer access int a and int b. You can't just do something like a inside here and think that this can be used up here. These are in two completely different scopes. This is one function and this is another function, and they're completely separate from each other. When you type in 5 and 5, it goes in order. So int a is the first one, so 5 gets placed into here, and this 5 gets placed into b. So now that we need to make use of them, we can simply change this to a and change this one to b. Now if we run the code, we should still get 10, but now our function works a bit better. We can give it a set of data. So if we actually just put zeros instead of here, then we should get 100 returned. Perfect. So now that we've figured out how to do this, let's have a look at different ways that we can make use of this function. So let's say we had a situation where we did console write, enter a number, and we had int num equals convert to int32, and then you're converting the console.readline. And let's wrap this inside a function. So before, what I was doing is simply just returning back an int. It was static int read int. And then we took these two lines and placed it straight inside here and removed the fact that we have an integer and simply just change it to a return. And what this now will say is, let's output enter a number to the console, let the user type it in inside the console read line and then read it in, convert it to an integer and then give it back to whatever calls it. So now we can get rid of this and get rid of this convert and simply just type in read int inside here. And after that line, let's just print it out to make sure it's worked okay. Enter a number, 10. Press enter and we have 10 again. And that's fine, except if we want to use this in another case, for example, if we have num1, maybe we don't actually want to enter a number. Maybe this time it's going to be enter an angle, or something of this sort. So what we can do, if we undo that, we can actually introduce a string message. And what this will do now is actually specify the message that we put in here. Maybe there's a situation where we always want to enter something. So maybe we can just replace this and put a string interpolation and wrap this number around in the curly brace and replace it to message. So then in here, we can say enter a, and then we can pass the string variable, which will get placed in here. So if this is a number, then we can type a number, and maybe this is something like an angle. And then here we can type an angle. So we have 10, enter a number, and then there you go, it says enter an angle. And then we can have 100, and that's working as well. Alternatively, if you want to specify the entire message, then you can remove these and keep it like this. And then in both of these situations, we can say enter a number and copy that down like this and make sure you put the colon at the end followed by the space. There we go. Enter a number 10, enter an angle 20. Maybe there's a situation where this text actually changed and you just want it to be angle, and if you run that again, then you'll see that these are completely different now. One says enter a number and one says angle. But this gives us a lot of flexibility in what we pass in. If we keep it as enter A and then let the user decide on what this section is, then you rule out any opportunity to be able to do that option. If you wanted to prevent the colon and the space always being at the end, you can actually just add that in manually. If we bring back the string interpolation, we can say colon followed by a space, so you don't have to remember to always put that in. There we go, so that's doing the exact same thing, and we're actually just reducing the amount of repetition. Because we have to remember to put a colon followed by a space inside here, we might just forget it, and then when you leave it like this, then the code's going to look ugly because it looks like this, and it's all stuck together. So let's make use of these two functions, and let's see if we can write a really basic calculator. We can say int first num equals read int, and then we can say enter first number, and then duplicate that down, change first to second, and then change this also to second. And then inside a console write line, we can actually have the add function, and we can type in first number, and then we can type in second number. And if you don't want to call a function inside here, you could actually just make another int, and we can say int result equals add, and just bring this line over to here, and then in the console write line, you can just print the result. There we go. So we read in both the values, execute the add function, and then return it back to the user using a console write line. So these are the other ones, and then here they are. So if we do 50, and we do 50 again, and you see that I've messed up because we have double colons now. So although our calculator did indeed work, let's just go and correct that, so we can take these off now, because we added it inside here. 50 and 25, we should get 75. Perfect, so now we've made a little basic calculator by simply making use of these functions. And if we just expand this just to show you what it would have looked like. So we go in from this, and we place our message inside to here, and then we have our convert line, just like this. And then if we duplicate that down, we can change this to second num, and that to second number. And then as for the result, we can say first num plus second num. There we go. You can see the code is drastically longer, and it's a bit meaningless to have duplicate code. This is literally the exact same line in both of these sections, except for the fact that this says first and this says second, and we're storing in first and we're storing in second. So let's undo that and get back to our more efficient code. There we go. You can see that these three lines are considerably shorter and easier to read. This is telling us we want to read an integer, here is the value, and we want to return it inside our first num, and so on and so forth. Let's have a look at another example where we can make use of this. So we can have a string called name, and we can read this in from the console, console.readline. But we need to output a message, so we can have another console write, and we can say enter your name, and then we can have this twice, and we can do enter your age, and then have an int age. But of course, we don't want to be using this approach and putting a console write line inside here with a convert to int32, because although this is actually technically correct, now we're undoing the point of our function. So let's change this into our read int, and then as for our message, well, we have the message right here, and again, we don't need the space colons, let's remove that. And then as for the name, we can actually do this differently. So this is actually going to do a string variable. So what we want to do, instead of having read int, we can have another function called read string, another string message parameter, and then do exactly the same thing. Have a console write, and we can place string interpolation, and place a message inside here, followed by colon space, and then we can just simply return the console.readline. There we go, and instead of doing all of this, we can actually just put our read string inside here, and then place our enter your name inside here, just without the colon space because we don't need that. So now we've reduced this section to 2 lines as well. So now what we can do is have a string details, and make that equal to a function that we're going to use now. We can say user details if we want to give it the name and give it the age. And that'll give us back a string that we can print to the console, so we can say details. So let's go ahead and make use of this function. So we can have a static, and it's going to return us back a string because we're placing it inside the string. And then it's going to be user details, and then our name is a string, our age is an int, and then inside here we just want to concatenate them 2 values together. So we can say hello, my name is, name, and my age is age. And because that's returning us back with a string, we can make use of it inside string details, or we can place this straight inside the console write line. Let's leave it as a function call, assign it into string details, and then print out to the screen. Let's just skip over these sections, enter your name, Abba, enter your age 23, and then there you go. Hello, my name is Abba and my age is 23. So this is how we can make use of parameters inside our functions so we can actually give it some sort of data that's meaningful. If you didn't use parameters, then what you're going to have to face is, for example, what we showed you with this integer. If you don't use parameters, then you're going to have situations like I showed you before with this integer function. It returns back an integer, but it only gave us the value of 5 plus 5. I mean, technically you don't need to return anything, you can actually just keep this a void and just wrap this around in console write line. The only issue with this approach is you don't have any option other than to print it out to the screen. What if you didn't want to print it out to the screen and you simply just wanted to return the calculation and then store it inside another variable? This doesn't give you the flexibility of that. So we change this into an int, and instead of return it back to the console, we just return back the pure value, and then if the user decides that they want to print this out to the screen, that's fine. Like here, we've made a decision that we want to print it out. But let's just say we had a variable that said int calculation, and then we placed that inside, but we actually never wanted to print it. Maybe we kept it like this, and then used calc for something else down below, or maybe that was something like storing inside a database. Not everything will be printed out to the screen for the user to see. The best thing to do is return the values in their purest form, because you never know what the developer or the user is going to make use of that data later on down the line. Keeping it in its purest form is the best way possible. For example, in this case, we're actually reading back the integer and then print it out to the screen. But in this exact case, which is the best case scenario that I just showed you, we're actually making use of first num and second num, but first num and second num are never actually put it to the screen, it's always just used for the calculation. If we use console write line to print out first num and second num, then we're not going to be able to use it inside our calculation, and therefore our very basic calculator is now being rendered pointless. So read int and add all return back values that we can use in their purest form, and that is the whole goal of parameters. So now that we've covered parameters that are always going to be required, let's have a look at another concept called optional parameters. So we had a static int add, and we had int a and int b for example, and then we simply just returned a plus b like we used in the previous examples. If we have an int result and we want to call that function and we give it the value 5 and 5 and then print out to the screen, everything runs okay because we've added in exactly what we expect. Let's say we don't actually have this additional 5. Of course this doesn't make any sense because we're meant to be adding two numbers, but just humour me for a minute. Then what this will do is says there's no argument given that corresponds to the parameter b. Now of course this is a problem because it's a red underline, which means if we try and run the code we're going to get an issue. Let's say you were creating some sort of system that if you entered both values, it uses both values, but if you only entered one, it automatically sets the second value to something else. And we can achieve this behavior using optional parameters. So an optional parameter doesn't exactly mean quite optional, it kind of just means that it's going to be optional, but you can also give it a default value. This will always add two numbers, a and b. Even if we make a or b optional, it's going to still need two numbers to add in order for the function to run. So in order to make a parameter optional, let's just say we want to make b optional. We can type in an equals straight after it and actually give it a value. So as you can see, our syntax error is now gone, and if we run the code, we should get 55. And the reason why this works is a is now 5. If we hover over here, we can see a is 5, and then the square brackets around the int b actually denotes that it's optional, and it says int b equals 50 because we have that here. So it's actually using this as 50, and if we don't specify the second parameter, then it's practically just doing this, which is completely fine. So the reason why I said it's not quite optional is because you still need to give it a value. Of course in here you can use the default keyword. In the case of an integer, the default value is actually 0. So if we just run that code now, it's going to say 5 plus 0, which is just 5. So it can be optional, but you still need to give it some sort of value. Of course, if you're doing a calculator and you're adding two values, if you only specify the first one, then adding 0 to it is simply not going to change it. So 0 or default is going to be the best user case when you're dealing with default values with integers. So another way you can actually specify this is by inserting this thing called an attribute. If we remove this equals 0, and just before the int, we can type in open bracket, close bracket, and type in optional with a capital O, and then you're going to get a red underline. If you hover over it, it says we need to include this extra library, which will import it at the top of our code, as you can see here. Now that this is available, it says indicates that a parameter is optional, and what this will do by default is it'll give you the basic value for this number. So what I mean by that is we can type in here, just to show you this, b equals and then b, and this will just give you the default value based on the data type, and as we just said a minute ago, that value is actually going to be 0. There you go, b is 0, so all it's doing is saying 5 plus 0 equals 5. So that's another way of doing it, or you could just leave it as I said before. You can say int b equals default, or int b equals 0, it's completely up to you. I prefer using the default keyword, so you don't have to keep remembering which different data types have the default values. In the integers case it's 0, but I just like leaving the default, and we can get rid of this line now. Let's have a look at different situations where this will be helpful. If you had a function called print name, and we had a string name in here, and then we can simply just say console write line, my name is, and then name. This is quite easy to use, so we can say print name, and then place ABBA inside the brackets, and then run the code, and we get ABBA printed to the screen, and that's fine. But let's say if we had someone else's name in there, as Joe for example, then we get Joe to the screen, and let's just say as the developer, you only want to default this to ABBA if you don't actually insert anything. So now if you don't insert anything, of course we're going to get a compiler error because we need a parameter. But if we assume what we did here and just follow the same approach, if we use default, then it's going to give us nothing because the default value for a string is just empty quotes, which is just nothing. But instead of default, we can actually specify a value. So we can say, if no one types their name inside the brackets, then use ABBA. There we go. So you can have this optional parameter that defaults to something, and if someone types in Joe or whatever inside the print name function, then the default optional parameter is not going to be used, since this will be overridden if you have a parameter placed inside here. So now the ABBA is going to get overridden by the Joe, because this is actually the parameter that's being used in the function. So you've looked at functions with normal parameters, optional parameters, and now let's take a look at name parameters. So let's say you had a situation where you had string name, ABBA, int age equals 23, and string address equals 1 something road. And then you had a function that would simply print these details out to the console. So we have static void, print details, string name, int age, string address. So you have 3 console write lines that just print out a name value pair, just like this. And then when you go to call this function, what you're going to have to do is specify the name, then the age, then the address, in that specific order as per the parameters show. If you try and run the code now, we should get the desired output. Perfect. Let's say for example you wanted to rearrange the parameters and put age first. You'll see we have a compiler error now because age and name are in the wrong order. String name should be first and int age should be second. We can still achieve this by using something called name parameters. We don't have to stick to this order if we tell the compiler which parameter we're directly talking about. So we can say age, because our parameter is now called age, as you can see it's been highlighted, and then after the colon it's the variables that we're talking about. So it just happens to be that age is the same value as the age. So maybe we can change this to age input, and place input at the end of these, so then we can have age equals the age input, and name parameter equals the name input, and the address parameter equals the address input. Now we can have it like this, and to make it look even better, you can actually add new lines in here just to break it off like this, and this is a similar pattern that you'll see in normal production code. Putting a space here can separate them out a little bit, and there we go. It doesn't matter which order that we put these in right now. We can even put address first, and it'll still work okay, and if we run it, you should still get exactly the same output, it's just specified in a different way. So let's just have a little recap. To make use of name parameters, you don't need to do anything to the original function, you just write it exactly the way you're used to doing. You specify the parameters in the order that you think is sensible, and when you go to call it, you can simply just type in the parameter's name first, followed by colon, and then the variable name that you want to address. Once you've done that, then you can use name parameters. You can go back to using the normal function by just getting rid of the name followed by the colon, and just replacing all of the parameters using the correct order and the original variables, instead of the new notation having name colon followed by name input. So far we've covered functions with no parameters, normal parameters, optional parameters, named parameters, and let's look at a concept called out parameters. Let's demonstrate a quick example. So if we call a function called test, and we pass in a value, and let's just make this work, so we can have an int num equals 0, and then we have a test function. So we can say static void test, and we can say int num, and inside here let's make num the value of 5. Now in this example, if we print out num to the screen, what do you think is going to happen? Is num going to take the value of 5, or is it going to keep the value of 0? I'll give you a second to think, and let's run the code. So let's run it and see what happens. And if you guess 5, you are indeed incorrect, and if you guess 0, you are correct. And the reason why it's not 5 is because when you pass in num inside this parameter, it just becomes a parameter, and therefore it becomes a local variable. Even though these two variables are actually called exactly the same thing, you'll see that when I highlight it, it only highlights this one and doesn't highlight this one, and the same is true for this. It highlights these three references, but not the ones down here. The num variable is only accessible in each other's scope. This one is available through here, and this one is available through here and here. Therefore, if we use this assignment, then it's actually doing nothing. If we print out num inside here, num equals num, and then we print that, we can see that it is assigned the value 5. But because it doesn't do anything at the end of this function, then it simply doesn't get returned back or anything happens to it. So let's see how we can make this into 5 when it gets printed out here. So the options that we have is we can actually make this void an integer. And we can say num equals 5, and then we can return num, or alternatively we could simply just return 5 and not do both of these lines. So if we run that now, then we still get 0. And the reason why we get 0 is the test function is being called and it returns back an integer, but we're simply not doing anything with it. So we can say num equals the return value of this function, which will be 5, and now if we run it, we should see our 5. Perfect. Now this is a little bit cumbersome, and let's say you wanted to return a value and return back another value at the same time, then what are your options? So let me show you a quick example. When you're using int.tryparse, we have a string s, an out, int result, and a bool. So what this function is effectively doing is return you back a true or false value to dictate whether or not the conversion has been successful, and it's also returned you an out int result. And what this means is you can actually specify an integer variable straight inside the brackets, so in essence this function has gave you back two values. It's gave you back something from the integer parameter, and it's also returned back a boolean variable. So let's convert this to our code and see what the third option is of trying to return back 5 over to this. So if we just comment out this line, and as you saw in the try parse, you simply just need to put the word out just before here. Out int num. Now we don't actually need to return anything in this specific example because we want to just change a num variable using the out parameter. But if we wanted to return something separate to the num, like a boolean like the try parse did, then we have that option. So we can return back true, but just before we return back true, as there's a red underline here, it will say that the out parameter num must be assigned. So we need to give num a value. We give it the value 5 because what we're actually doing here, even if we double click on this, we'll still get num being selected here because the scope is still exactly the same. Now except what's happening is when this variable gets returned, it actually gets put into the variable that it was initially called with. So let's fix these compiler errors first. So the reason why it's complaining is because we need to give it the out keyword. So when we're specifying in try parse, our first parameter is a string. So if the user types in 123, we put in the first parameter, and then we'd say out int result or something along them lines. You have an out, and then you say you want to make a new integer and you want to call it result. See, in our case, we don't need to put int just like in here because we've already created our num. So the only keyword we need is out followed by a space. And now of course we're trying to assign this back into an integer, which we don't need anymore because this is a boolean. So we can say bool success equals test out num. So you print out success, print them both to screen now, we should have 5 and true. The true comes from the return true, and the 5 comes from num equals 5. So what's actually happening here is we're creating our new integer. We're passing it into this function, but we're also telling it that it's going to be an out parameter, so this function can still output things to our number variable, and then when it gets placed inside here, we assign num equal to 5, and then just because we have a bool, we have to return true or we can return false. Of course, we could just take this out completely, take away the return true, and just keep this as test. Of course, in both scenarios, these aren't actually doing anything, they're just completely random values, it's just made for demonstration. So bool is return back true or false, doesn't actually mean anything, I was just demonstrating that you can have two return values from one function. There we go, we get 5 when we run it just like this. So now I've completed this little example, let's have a look at how it's used in the real world. So before we continue, let's see if we can rewrite the try parse function in our code. So it's going to be a static, returns back a bool, we have a try parse, our first parameter is a string s, and our second parameter is out int result, and then inside there we can just do result equals to 0, and then we can return back true. Of course we actually need to do conversions inside here if we want this function to work, but I'm just showing you for demonstration purpose. If we uncomment this line out and have a look at the parameters again, you'll see that now they line up perfectly. String s, out int result, and it returns back a bool, which we have exactly the same here. There you go. Bool int.tryparse, string s, out int result. So that's how this function has been declared. Of course they're doing something inside the body that can take in the string, convert it to an integer, place it inside result, and then return whether or not the function has been executed successfully. So now that we understand how to make an example and how to make the try parse function ourselves, and to give you the declaration, let's have a look at a real world example. So if we had a list of string, and we had our shopping list that was used from the examples, we can have list string, and let's just create our own initializer just with coffee and milk inside. There we go. So now that we've created that, we've got our shopping list. If we wanted to find something inside the shopping list, we have the function index of. And what that will do, as it says here, searches for the specified object and returns the 0-base index of the first occurrence. So if we were to search for coffee, then we should get returned back 0. So let's try and run this and put it in the console write line and see what the value is. There we go, we get 0 since it's the first item, and if we place milk inside here, we should get back 1. There we go. So let's try and rewrite this function into our own code. So all this will do is loop around all of the positions until it finds it, and it'll find the first one, and it'll return us back the index. So in this case, there's no out parameters, but there is a return value. So we can also include an out parameter, and then instead of assigning the value of -1, we can actually assign the value of true or false to dictate whether or not that we found it. So let's write the code normally in here, and then let's wrap it around in a function. So we can say int index equals -1, because we want it to start at a value that we know is incorrect. Since the lists are from 0 onwards, the value is only ever -1, then that means it's not in the list. Then we can then create a for loop, int I equals 0, shopping list dot count, because we want to go through every single item inside the shopping list. And inside here, we want to do a lowercase comparison. So we can do if the shopping list, square bracket I, dot to lower, dot equals, and then we want to make that equal to just something that we're going to type in statically, so we can just say coffee. We can make this into a parameter after, but this is just for demonstration purposes. So we have a bracket, and if we found that match, then we can say index equals to I, because the index of the position that we want to find must be up to I, because that's the one that we've made a match with. And we don't need an else inside here. We don't need to set an else inside here to make it equal to -1, because if it simply doesn't find it, then the index variable won't change its value, so it will always stay -1 if it doesn't find anything. So after the for loop is run, let's just print index out to the screen. There we go, we have 0, and if we change this over to milk, and run it again, then we actually have 1 placed inside here. Perfect. So now what our function is doing is giving us the values of the index if it finds it. Now if you type in something else, if you just add another k in, let's see what happens, then we get -1. And -1 means that it's incorrect and it hasn't found it. And what we can do inside here, we can say if the index is greater than -1, then we can say found, or else we can say not found. So let's run the code now and see if we get a visual representation. Not found, and if we change this back to milk, and run it again, then we get found. Perfect. So as you can see here, we're actually checking if the value is greater than -1, but it'd be easier if you had a variable called found, and it is actually a boolean variable. So we can make a bool found and make that equal to an if statement condition. So we can say something like index is greater than -1, which is exactly what we had here a second ago. And because this is a condition, it's either going to return back true or false, and it's going to place the value inside found, and then we're going to use found inside here. This is easier logic to understand. If this is true, then it's found. If this is not true, then it's not found. True, true, false, false. It's quite really straightforward and very easy and clear. you have an index, and you have whether or not it's been found. So let's try and wrap this around inside a function. So just as the try parse does, it returns us back with a bool, which in this case will be our found, and it also gives us back an integer result, but in this case it's going to be our index. So let's see what we can do to write this. So we can have a static, we want to return back the bool, and we can say find in list. We need to give it the item we're going to find, so we're going to need a string s. We need a string s for the item that we're going to find. We need to give it the list as well, and then finally we need our out int index. There we go. So let's comment out this code here. And let's copy this down into our function and see what we need to do. So index has the value of -1. We don't need the integer variable declaration here because we've already declared it inside the parameter. So after declaring it inside here, we give it the value of -1. -1 indicates it hasn't been found since the index are 0 based. So instead of shopping list, we now just have list and list here as well. And then instead of having it being equal to milk, we actually want to use our s variable. And to make it better, we can convert it to lowercase, just so we have lowercase conversions on both sides of the equals. If we find a match between the list that we've passed in and the s variable, which is our search term that we've passed in, then we assign I to the value of index. And then it's still got a red underline because we haven't returned back bool.